Good evening, ladies and gentlemen, all the professionals who have gathered here, who have spared time on a Friday, sorry. A warm welcome on behalf of Epicons and Wide Angle Forum. I'm architect Priya Gokhale, and I will be guiding you through this wonderful program. For starts, may I say that today is a rather auspicious day. The reason, today is the day where this particular symbol of our great country was actually born. And if you see on the internet also, there's a lot of information which tells us that today is the day, 75 years ago exactly, when the tricolor was adopted as the national flag of this great nation. On this note, friends, ladies and gentlemen, respected professionals, I welcome all of you to this webinar 132, which is Think Beyond Green, Part 1. On this note, I would like to inform you that we'll be having 4 speakers. All of them will be telling you about things that sometimes you may know about, some things will definitely be new for you. And of course, we will be having a special question answer session also. And without further ado, I would like to request Poonam to tell you a little about EFC. Good evening, good afternoon, and welcome to all of you. Over to you, Poonam.
Thank you so much, Priya ma'am. Hi, good afternoon, everyone. I, Poonam Ka, working as an architect in Epicons Consultants Private Limited. Once again, welcome everyone on behalf of EFC for this webinar. EFC has been conducting a series of workshops and webinars since 1999. The training activity is conducted under the umbrella of Epicons Consultants Private Limited, which is a ISO 9001-2015 certified company. One of our defined objective is imparting knowledge to interested parties and societies at large. Our principal inspiration, a philosopher, friend, and guru, late engineer A.P. Remedios. EFC has conducted 79 workshops in last 21 years and 32 webinars in last 2 years. We started webinar series since lockdown through our unit EFC dedicated to training. EFC is an humble effort to create knowledge sharing platform and develop a facility for continued education for practicing architects, structural engineers, corporate consultants, government and semi-government authorities, builders and developers, faculties and students. This is a timeline of our previous webinars conducted, and today we are presenting before you our webinar 132, Think Beyond Green, Part 1. This is a team EFC, our pillars of team EFC. So Mr. Jain Pulkarni, our managing director, our directors, Mr. Anand Pulkarni, Mr. Ravindra Deshpande, Mr. Arvind Parlekar, and our unit heads, Mr. Parashar Moge and Mr. P.P. Pandey. Thank you so much. I would request Priya ma'am to please continue ahead.
Thank you. That was Poonam from EFC giving you that very short introduction about EFC. Friends, I'm Priya Gokhale. I'm an architect. I'm a journalist, and I head the media company which is called Wide Angle Forum. I'll be quick. Can we have the next slide? Under Wide Angle Forum, we have 6 activities that we do, all under the umbrella of Wide Angle Forum. By Wide Angle Forum, I mean WIDE stands for Working in Design and Enterprise. And basically what we do is we connect creative minds. Next slide, please. So the first activity or initiative that we do is programs, interesting programs, presentations, talk shows, webinars, exhibitions, basically connecting people under the umbrella of design and construction. Second is the Aspire Academy, where we do workshops, grooming sessions, seminar, career counseling, and so much more, both for students and professionals. Third is we have a very interesting division called SUFFER, which is Seeking and Finding Architectural Rejuvenation. These are study tours where we go to a place outside our office and we come back rejuvenated. Of course, we have a design magazine. It's a pan-Indian magazine called Design Vista. And we are 3 issues old. And the most recent issue was on 50 interesting homes. And of course, finally, we have something which is very close to my heart, which is a book club that also we have, where we collectively come together, we explore interesting books, not necessarily in the design segment, but otherwise also. So friends, these 5 activities that we do are supported by the YouTube channel called Wide Angle Forum. And this is who we are. I would love to connect with all of you. We have another branch office in Ahmednagar and expanding to all over Maharashtra. Thank you. Namaste. And on this note, I request Jain Pulkarni sir and PP Pandey sir of Epicons and Epicons Friends of Concrete to take the mic. Thank you very much.
Good afternoon. I hope my voice is audible.
Yes,
Yeah.
sir.
Okay. Good afternoon. I welcome you on behalf of Epicon Friends of Concrete for this webinar 132, Think Beyond Green. Let us understand how we started thinking about this webinar. In fact, we planned a day-long workshop, physical, of course, on 21st March 2020, having deliberations on 9 different topics, and still the subject was not getting covered completely. Unfortunately, it could not happen because of Corona pandemic, and now still it is difficult to conduct offline program in a closed auditorium, that too day long. So we have decided to divide this into 3 to 4 parts, and today we are at part 1. Let us look at the background. Construction industry is driver of the world economy, maybe number 1. At same time, there are certain side effects or byproduct. This sector was responsible for 38% energy related to carbon dioxide emission globally and 24% of total energy and processes related to carbon dioxide in India. This is going to be increasing in coming years and expected to be doubled by 2060, not too far. For years now, the industry has focused its climate effort on operational energy like lighting, heating, cooling, plug loads. However, looking at the exponential growth of the building industry and its tremendous direct and indirect impact on ecological balance, this is not enough. The production of lots of material also involve chemical processes releasing additional greenhouse gases. This leads to depletion of natural resources and erosion of ecosystems. We need to look at our design processes differently and examine the general practices that we are following critically. The application of alternative or additives and materials, techniques and systems can reduce 90% of the CO2 emission. This webinar hopes to get us closer to understand the various new possibilities that we can work with to help us get nearer to our sustainability goals. Now, as a matter of policy, state and central government, semi-government and corporate projects are making it compulsory to design the project for a certain green building rating. Now, please understand this is not enough. We need to imbibe this in our thinking and make it our culture to save energy and carbon dioxide emission wherever possible. What we have to do is we have to think beyond green. Thank you. Priya, please take over.
Thank you very much, sir. Indeed, that was an inspiring piece of introductory way in which Jain sir has told all of us, each one of us, why this process is very necessary. And I think all of us are part of this. To move on, I would like to introduce our first speakers today. As you can see on the screen, I will be reading out. But before that, I would like to tell you something which is interesting, as in her designation is Head of ESG and Sustainability Consultancy. So where ESG interestingly means environmental, social governance. Dhwani, you can correct me if I'm wrong. And I find it very interesting because, it's most of the time architects who think that, wow, we are doing something which is related to environment and culture and changing somebody's mindset. So there are lots of learnings for me also in this. And now I will formally introduce her to you. Apart from her many designations and her many degrees, Dhwani has 17 years of professional experience with focus in ESG, carbon neutrality, and sustainability. And I don't think it'll be wrong for me to say that these words were once upon a time very fancy terminologies, but today, as Jayan sir has said, they are going to be imbibed in each one of us. Vani has a very strong track record, has worked as vice president projects in a multinational development bank with projects in India and abroad, experience of working in Paris with projects across the globe, for example, Israel, Uganda, China, and various cities within India, to name a few. She has, of course, been awarded many citations and accolades, some of them being the Global PJM Star Award in 2019, just a few years back, and the Circle Excellence India Award as recently as 2018 and 2020. She's part of the Core Net Global Committee for Post-Pandemic Workplace Design, which, as all of us know, is a very exciting segment to be in. And of course, Vani is an important part of CBRE, and her designation is Senior Associate Director, National Lead, Design Advisory and Management. I would like to introduce Engineer Vivek Mewada also here, who is the Assistant General Manager, Design Advisory and Management at CBRE. Both, of course, have a demonstrated history of working generally also in the field of environment and sustainability. To introduce Vivek Mewada in a similar formal manner, of course, an MTech in Sustainable Development and Climate Change at the very one and only SEP University, and now Assistant General Manager, ESG and Sustainability at CBRE Mumbai since June 2020. Vivek has extensive expertise in most of the categories of green and environment, architecture and engineering as we see it today. For example, to name a few, green certification areas, wellness certifications, environment impact assessment, which is a very important part of what we do today. And of course, on a very ground root level, design and execution of solar systems, rainwater harvesting, and solid waste management system, which is absolutely the grassroots of environment sensitivity, as I would like to put it. He has also a presence in several publications, which is a very important part. After all, we as professionals need to disseminate this knowledge to a vast readership. And he has written extensively on residential buildings in India with specific reference to energy use projections and savings potential. Ladies and gentlemen, I give you Architect Dhwani and Engineer Vivek. I'm sure this is going to be an exciting roller coaster ride. We are still in the part one. And on this note, Dhwani, I hand it over to you and Vivek. Thank you very much.
Thank you, Priya. That was a very fancy introduction to ourselves. We were impressed ourselves, I'm sure. Vivek has the same thing to say. Having said that, while no one is really an expert when it comes to sustainability, we all try our wit. Some have a little more knowledge and experience over the others, but that's about it. There's a vast amount of science and learnings to do there. Mr. Kulkarni has given a preamble which sort of puts things in perspective. The way we are going to run the next 1 hour or so is between Vivek and myself. I will take you through the entire overview of where we stand today, where we have come from, where we stand today, which are the various ways in which ways, methodologies, processes, products in which you can sort of categorize sustainability, report sustainability, and comprehensively understand sustainability. Vivek is then going to take over from me and, like Priya said, take you to the grassroots level and brass tacks of hands-on experience of what site engineers, construction industry professionals can take it up. We are not going to cover a few things, rather many things that we will not be able to do justice to in a single hour. But things such as design aspects and things which are quite, already known by everyone are things that we are going to sort of try and not touch upon, given the sensitivity of time. I'm going to shortly share my screen and also switch the video off to avoid any lags. Please tell me once you can see my screen.
Yes, Dhwani.
Is my screen visible?
Yes, Dhwani, it is visible.
Yes.
Yes, it is.
Thank you. So, thinking beyond green, I think it's a very exciting title to begin with, given that green has a very strict connotation in everyone's mind, and it's important that we sort of break through free from that. Since in the last decade or so, the definitions have changed, the impacts have changed, and the way we solution it has also changed. Mr. Kulkarni pointed out my designation, and that in itself is something to say. We did not have these terminologies a decade ago, and today it's become the biggest buzzword in the industry. So I'm going to cover a very high-level overview of things, and I would want to begin with the perspective and taking a few steps back. I'm not sure how many of you know what an Earth Overshoot Day is. Well, I myself did not know a few years ago. Natural resources our planet is capable of generating in 1 year. That is, if X is the amount of resources you need to survive on the planet in a year, a day when the X depletes itself. Now, in an ideal situation, if everything is sustainable, you would say that it has to end on 31st December. That's when the year ends, and that's when your resources for that particular year ends. But it so happens in 21, we overshot this limit on 29th July, which is huge. In other words, it means we need 1.5 planet to survive for one single year. And I let this to sink in everyone's mind for a second. It needs a moment of silence and grief to say that we need 1.5 planet to survive for 1 year. Imagine the damage we are doing ourselves. In fact, WHO is preempting us that next week is when we will run out of resources for 2022. And we want to complain about BMC not being able to handle floods. Hello, we are damaging it. We are to blame first, and it's not like we can't do anything about it. Starting with grassroots levels and steps that we can take up as individuals to steps that we can do as game changers, as engineers and architects. We're going to run you through briefly what are the steps that we can take. But what does this essentially mean, and where are we going with this? It means rising GHGs, the greenhouse gases in the atmosphere, increasing global warming, greater exposure to the worst effects of climate change. We are talking about monsoon being the worst, the warmest day in summer ever in Mumbai, the coldest winter that Mumbai has ever seen, for that matter, the world has ever seen. So that's essentially global warming. And while we can talk facts about global warming, it all comes down to the fact that the resources are depleting, and it's about time we do something about it. Well, that was to give you a perspective of where we stand and the grave situation that we are in, and why thinking beyond green becomes so pertinent. Let's talk about the concept itself as the word sustainability, not as a literal English word, but what it means today as a concept. How old is it? I mean, the Earth itself, the planet itself, is billions of years old, but it's quite alarming that we woke up to the word sustainability only 35 years ago. In fact, the first time it appeared at a United Nations level, and when all countries started to talk about it, it was only in 1987 during the Brundtland meet, when we were all warned about the negative environmental consequences of economic development and globalization, of what industrialization is doing to the environment. Until then, it was all about the productivity, and we seldom talked about what it does to the environment. Fast forward 20 years, and 2010, United Nations put together a Millennium Development Goals, which were essentially to roadmap sustainability, not just in isolation of what green means, but what it does to the health, the education, living conditions, environmental, comprehensive sustainability, and gender equality. While these were very nascent at that stage, it did not take very long from 2010 to now, the 2030 agenda of the United Nations, which is on the Sustainability Development Goals, which in its true sense is what sustainability means. There are 17 such sustainability development goals identified, where each country, each organization, each individual, and each product in the market should be aware about, should be conscious about. And I will shortly take you through what these 17 goals are, but to say it in short, there are 169 targets which are categorized under these 17 goals, and meeting each target means taking actionable, smaller activities undertaken by an individual, and more so by the game changers, which are the engineers and architects, who will in turn be able to make the difference on built environment, and thereby the larger community or the society, and thereby the economy, either or we are talking about an organization or country or the globe at large. These are the 17 different sustainability goals. This is a lot to take within a minute that I'm going to talk about, but you can take this back and you can Google, and each of these have a very specific impact on the environment. We talk about no poverty, while this is an ideal situation, but how each one of us can make a difference, or each organization can make a difference, either through CSR activities or through their ESG actionable deliverables, towards no poverty, zero hunger, good health and well-being. And I will touch upon some of the standardization and codes and certifications that have been evolved across each of these attributes. Sometimes they are single attribute certifications, sometimes they are multiple attribute certifications, and some are very regional in nature, and some are very global, like you have the LEED certification, which is a global, and it touches upon only some of these attributes, not all. Gender equality, which has taken the forefront in the last decade again. I would talk about industry innovations and infrastructure, not limiting to the productivity of what it is about, but more comprehensive and integrated approach towards innovations. Peace, justice, and strong institutions. This is the governance bit, and at United Nations, we've realized, rather at that level, we've realized how, unless we are talking about governance and initiatives at governance level about peace, justice, and strong institutions, we cannot touch upon the lives of the people, which is the social aspect of the sustainability. And it's only when we talk about the social aspect of sustainability is when we can actually talk about the environmental aspect. I hope I'm making sense and I'm not going too fast. Mr. Kulkarni, please feel free to slow me down if it's required. This is a very, very huge and I won't say vague, but vast subject to cover. And one slide is barely any justice to it. So when you have to categorize these 17 different goals, the three pillars of sustainability, so to say, would be people, planet, and profit. When we talk about people, we are talking, like I said, the social aspect, the planet is the environmental aspect, and profit is taking it down to the economic section of it. When we talk of people, we are literally talking about the quality of life that we are able to give to the communities. We are talking about trying to connect with people on their literal requirements of day-to-day activities, literacy, obesity, so on and so forth. We are also touching upon the dependency ratio, the crime, housing, living costs, etc. When we talk about environmental, pretty straightforward, so to say, since most of us are now aware about the green initiatives you can take at the built environmental base. But it is not just about energy management, which is largely the myth. It is also to do with the water, the drinking water, the sanitation, the air pollution, the greenhouse gas emissions, like Mr. Kulkarni touched upon in the preamble. We're talking about indicators, monitoring, reduction programs, and broadly capturing the green factors across all of these. And finally, when it comes to the governance bit, which directly links to the economic and the profit part of it, we are talking about transportation, infrastructure, rail, air, traffic congestions, ease of doing business, tourism, GDP per capita, the city's importance in global economic networks, and what role it can play in the larger scheme of things. While these are only aspects and the three pillars of sustainability, fast forward present today, we talk about ESG, and like I was asked at the beginning when I just joined in what my designation means and what ESG stands for, environmental, social, and governance. the three pillars of sustainability literally being categorized and factored into reporting methodologies in a way that each organization has a target, a goal, a way to monitor whether we are reaching that target within the given time frame, and what are we doing as again organizations to reduce and reprogram in a way that we are conscious and aware about where we stand with each of these aspects. So how do we play a role in these aspects as the stakeholders, as people who are frontliners and are people who are actually responsible for all of these three pillars? First, we are the game changers, like I keep saying. We are the ones who make the products, we are the ones who develop the processes for it, and we are the ones who are responsible to execute these products and processes. So unless we are conscious about what, why, and how of each of these, we will not be able to make a real difference. And which is why I appreciate the efforts of EFC, the Epicons Friends of Concrete, in taking up such initiatives where the game changers in the industry are becoming more conscious towards ESG and sustainability at large. The second hierarchy in the system where we as stakeholders make a difference are we as the ambassadors. While the companies only manufacture green tagged products or materials or construction processes and equipment, we need to be the ambassadors to use them efficiently, to use them in the right manner. And thereby we become the main stakeholders to not only propagate as game changers, but also to become the ambassadors to take them forward. The third in the hierarchy at the infrastructure level would be the advisors, because we understand the grassroots levels of how this works, how this operates, and what, technically speaking, what it emits as carbon emissions, or what the impact it has on the entire life cycle of the project, and all the way until its deconstruction when it is deinstalled, what it does to the environment. Because we as technical people here and a group of professionals, we understand what it means at the end of game. We need to become the right advisors to the clients or projects or infrastructures within the cities or our individual sites, where we can take this forward. And finally, we become the influencers, which is the society at large. When we exactly what we are doing at this moment is we are trying to influence and play a role in the entire game of how, from becoming the designers to the executors to taking it all the way into operations, how we can influence the entire process. So there are various ways of standardizing this. There are codes, there are bylaws, there are also green incentives that each country and each state, for that matter, gives you, right from FSI incentives, or we are talking about how much you can build on a particular land, you can gain credits. There are also incentives in terms of the premiums the occupiers would pay as rent on a building which is more sustainability conscious versus a standard design building. So there are various ways of standardizing this. There are various certifications in the market. Now, these are not just competition to each other. Each certification is different in its own league. Each certification is categorized differently, either because they are single attribute focused or they are multi-attribute focused. That's one way of categorizing. The other would be the focus areas. Some are more focused towards health and wellness. Some are more focused towards the quality of air. Some are more focused towards the energy management. And then there are some which are more focused towards the social and the governance aspects of it. One needs to be conscious of which one one needs to go to. And this is where the advisory bit comes in, where you as engineers and architects need to understand which is the most relevant to the client. Just because everyone's doing LEED, let's do LEED. Just because IGBC is probably cheaper than LEED, let's go for IGBC. That's not really the way to pick the right certification. Having said that, even within the asset class, there are various requirements for which each of these certifications can be categorized. Either it's because it's an existing building versus a new construction, or because of its asset class, that is, it's a hospitality, or it's a workplace commercial building, or a residential building, or a villa versus a individual home, or an infrastructure, open space, landscape, community, or at a city level. So depending on asset class, the kind of attribute you're looking at and the focus area, one should select the right certification. I'm going to take you through a few examples. There are many more available within India and globally. Two most widely used global ones are BREEAM and LEED. BREEAM is for both the existing buildings and new fit outs and new refurbishments. They're also there for at infrastructure and community level. The managing organization is BREE Global. The focus areas are performance and energy, health and well-being, transport, water, materials. They're quite similar to what LEED does. The one good difference with LEED is that LEED, I'm not talking too much about neither IGPC because I'm sure most of you know about it. And for the longest time, the myth has been LEED and IGPC equals to green. That's the myth I'm hoping that at the end of 1 hour we would have broken. So the difference between BREEAM and LEED or IGPC is that under LEED and IGPC, there are further categorization of each asset class. For example, there is a very specific IGPC green factories. And I say this because I understand a lot of you at EFC, for example, are involved into industrial architecture. So when it comes to specific to factories, warehouses, industries, IGPC has a very specific relevant certification there, which may not be there in all kinds of certification. And it's very India specific versus LEED being a more US based and a global certification. So some of the products may or may not be available. So one has to be very conscious of which certification at what point one goes for. The others, some of them are Green Globes, LBC. Green Globes is again very similar, but in India it's not very prevalent. Neither is it so much in US, but in Canada it is very prevalent. LBC is the Living Building Challenge. This is an interesting one. It is yet to pick up speed in India, but it largely talks about open areas. Spaces like landscapes, infrastructure projects, partial renovations, and half-done projects which are yet to take speed, but they're still open to public. I would talk about parks and neighborhoods, campuses, and this focuses on livability and happiness factor. Now there is also a happiness factor which has a particular way of scoring, which has nothing to do with energy management for that matter. But this is something to do with a good vibe that you call traditionally. You would say if you're looking for an apartment, let's say, you would be accompanied by the agent, and he would take you to various homes, and you would say there are some homes which is giving me a good vibe. Now, there is now a scientific way to define what this good vibe means. It means that it gives you the right amount of oxygen, it gives you the right amount of daylight, it gives you some amount of calmness because of the noise, the acoustic levels, the pollution levels, so on and so forth. And that's what you can all put together to call it a good vibe. There are various certifications around it. Like WELL certification is one of them, which is a global certification. In fact, I happen to be a WELL AP when in India there were only about 13, 14 WELL APs. Now there are many, many more. And it's become almost a given for most multinational companies to go under a WELL certification. It's administered by the International Wellbeing Institute. And this, so to say, is the good vibe I was talking about. It touches upon various factors like the air, water, nourishment, which is quite often ignored and forgotten, but an important part of well-being. When it comes to even built environment, what you serve in the canteen, how is it stored, and what nutritional messaging are you giving to your employees or inhabitants of that building or space through the design. Biophilia, light, movement, thermal comfort, sound, material, mind, community, innovations. These are just some of the factors. They all seem like words at this moment, but give each word a moment to think and how it can impact the built environment. In fact, I can go on with this just wellness and health being, and I'm personally passionate about it and what it does to design. What are the factors we can keep in mind as architects and engineers when designing a well building or a well space or a well factory for that matter. But I'm not going to go in too far. I still have Vivek also covering some site related aspects. Some of the other certifications which are also in the market, and CBRE is already doing a lot of these certifications, are GEM, HSR. HSR is in fact very new in the market, which is only a post-COVID certification. This is purely from operations perspective. What are your cleaning protocols? What are your activities or actions that you are taking to ensure that everyone who enters into the building is safe from diseases, airborne diseases or waterborne diseases, and what are the actions you've taken. So they sort of give you an assurance seal at the end of the certification. It's not really a rating, but it sort of gives you a seal of assurance which you can put up on your doors and entrances to give every person who enters your building a sort of um, uh, assurance that this building is well maintained and is not going to make you fall sick, so to say. Edge is another very important international certification. It is the organization that manages it is the International Finance Corporation, and which is why a lot of investors bank upon it. In fact, a lot of real estate investors, you would have read in the newspapers now, even warehousing developers, etc., are looking at Edge certification, Edge Platinum, Edge Gold for their facilities. They are largely and primarily focused on energy, water, and the materials utilized in construction. That brings us to the big buzzword in the industry these days. That's the ESG reporting. In fact, SEBI has now recommended Jan 22 that all listed companies within SEBI's purview have to disclose their ESG aspects along with the annual reporting, which means that it's a matter of time that it becomes mandatory. While it's not mandatory yet, there are a lot of countries which have mandated it with the annual reports to disclose their ESG ratings. There are various formats under which you can be presenting your ESG reporting. GRISB is the most relevant to real estate business, and which is why I thought I should take a second on that. So it uses consistent assessment methodologies. There is a very standard scoring method of looking at the E aspect, the S, and the G, all the way from the board of directors governance aspect to the social aspect, which is how you're treating your employees, the leaves and your policies, your HR policies, your cleaning protocols, your FM policies, and the environmental aspect, which is the health, wellness, and sustainability of the built assets. And this is across the asset class and your entire portfolio, not just one project. Yeah, I'm not going to delve too long or too deeper. The approaches that we as industry professionals should take are 2 or 3 and very high level at this moment, but they can be broken down into actionable items, and certifications being one of them. And Vivek will cover on-site, hands-on things that you can do towards it. But LCA is one of the approaches you should take. LCA is a life cycle assessment approach where you don't think about any process or any product in isolation. You think about where it comes from. How do you think it was made? How do you think it was brought to the site? What happens to it to install it? Do I need, let's say, very high energy use to install it? Do I need large cranes to even put it up? And is it worth the entire effort in terms of the carbon emissions? And what happens to it, once it has lived its life? Can it be reused, recycled, readapted? Can the entire building itself be readapted into a different function, because it can go, as life of the building, it can go beyond? So it's important that we talk about not just upscaling, downscaling, and throughout the life cycle of the project, we talk about sustainability as a mainstreaming and not an isolation of a certification, of not an isolation of one product selection or one material selection, not one the type of concrete or the type of carpet, but we look at it across the life cycle of that product. The other would be being very footprint conscious. When we talk about footprint, very simply put, when you're walking on the beach, the footprint you leave behind is means where you walked and how you walked and how much pressure you put in on the sand. Similarly, when you build something, there is a footprint you leave behind. That is the amount of emissions you leave behind because there were certain materials transported to the site from a longer distance than what it could have been if it was local. It's just one of the examples, but across the life cycle, like I spoke, there is a footprint that you leave behind, and the smaller the footprint, the lesser impact you have in the environment. It is not rocket science, but this is very, very often ignored, and we should be very conscious about the material selection, the processes we use during construction, such that we leave behind a minimal footprint. And we can do this either through offsetting the energy, that is either using green energy, so to say, solar energy, wind energy, etc., or offsetting it by generating energy in a green way in another location and being able to offset its credits, reducing the carbon emissions and the use of energy in general, recycling and reusing. None of this is, again, rocket science, and in plain simple English put, these are not new to us as concepts, but it's important to put it in perspective of a built environment and a construction site, so that we as engineers are more conscious the next time we are on site. And finally, the approach we should take should be an integrated approach. In fact, the GBCI, that's the World Green Building Council, has made a lot of effort towards advancing. There are commitments made for 2030, 2050. In fact, 2050 commitment being 100% of built must operate at net zero carbon. When I say net zero, it means absolutely no carbon emissions into the air. This seems extremely ideal at this position, and I can assure you, even the buildings that they say that they are net zero are not really net zero. They're close to net zero. We haven't reached there yet, but it does not mean that we cannot. There are certain principles to keep in mind, like the measure and disclosing of the carbon. It's when you disclose is when you make a commitment to yourself. It's important to monitor and to report what is the current emission. Interesting to note, there is no baseline at this moment. ASHRAE 90.1 has a certain way of looking at what it should be, but there is no baseline made for each industry, and we are, as we speak, in that era where we are literally creating that baseline. We have a lot of clients we speak to, from HPE to EY to PwC, Boston Consulting Group, who are talking about creating this baseline for their particular industry, so such that all their future assets that they create are going to be below that baseline. Reducing the energy demand itself, green energy is one way of looking at it. That's why energy balance from the renewables, but reducing it in general by using, the most basic and obvious answer is like LED lighting, which all of us have adapted to now, which uses much lower energy than our normal fluorescent bulbs. And improving verification and rigor, that's a performance verification. This exercise should not be a one-time exercise where you've constructed, built, and forgotten about it. There should be a more regular, either quarterly or on an annual basis, a performance monitoring. In fact, a lot of companies like Barclays, for example, we're working with, has made it live monitoring, not doing it on an annual basis, but doing it live, monitoring it, looking at the performances. If there are any live tweaks that need to be done, a shutdown that needs to be done because you are surpassing a certain baseline, those actions are taken immediately. I am, Parashar, open to question and answers, but if you prefer, we can move on to Vivek and then take the Q&A at the very end, but I leave it to you how you'd like to strategize it. Over to you, Parashar.
Yeah, some questions are still coming up.
Parashar, we'll take it at end.
We'll take
Ah,
it at the
Parashar?
end. Yeah, we'll take it at
Because
the end of the lecture.
Sure. Thank you, Mr. Kulkarni.
Thank
Over to you, Vivek, to take us through brass tacks of what can be done on site.
Sure. Am I audible?
Yes.
yeah.
Yes.
Thank you. Thank you, everyone. Thank you, Dhwani, for taking an interesting PPT to give everyone the overview about the sustainability and the various certifications. Thank you, Epicons and team, for providing us the opportunity to share our knowledge. We are also students, but this is a good platform to share our knowledge as well. Uh, is my PPT visible on the screen?
Yeah.
Yes.
Okay. Dhwani has covered a lot of factors in terms of certification. What is the overall idea about sustainability? Last week, when myself and the Epicons team were discussing about the green, then Mr. Kulkarni did told Vivek certification becomes one aspect. But when a person who is working on the site and he wants to relate to sustainability, how can he incorporate? How can he get back to? How can he relate to sustainability in a way? So the entire PPT which I'm going to go through is keeping a person who is at site, usually the site engineer who is standing and he's viewing all the things from his perspective and he's trying to address sustainability. So I'll be just connecting the dots which are there. This is the chronology in which I'll be going. So wherein I'll be first involving who are the stakeholders, the key area of focus in terms of materials, designs, principal aspects in terms of waste management, safety, health, and at the end, emphasis on the knowledge which is there. As I told initially, on the site, when everyone is there, client, the architect, structural engineer, contractor, the green consultant himself. So yes, things are designed on paper, and yes, commitments and everything are given. But it is the site engineer who is the one who is responsible for the execution. So a question was raised initially when we were having discussion, Vivek, how can a civil engineer at site understand sustainability? How can he contribute to sustainability? My answer to sir was, sir, he is the sole driver of sustainability. He is the one who in fact touches each and every aspect of sustainability, starting from the landscaping to water to air to the indoor air quality, even the materials which are there. It's only the connect, the relation, how he's relating each and every aspect of sustainability. That is the emphasis which I will be throwing on the highlights in this presentation. uh, so when a site on a site engineer, when a person is standing, then what are the principal key areas of focus in terms of sustainability, which he can dive into? So starting, so these are just bullet points. I'll be diving into each and every section in the subsequent slides. So first, starting, it starts the first is the structural and the architectural design. So how is the design of the building made? How is the envelope designed? Apart from that, what is the design? What is the glass selected? Water conservation, okay, you have selected a tap, but are we saving the water? Are we preventing the leakages or so? Energy conservation, yes, energy is used for construction, but we have to look for each and every attempt to save the energy on site. So usefulness of the energy which is there. Renewable energy, though on a site it becomes a difficult aspect, but we have to look forward. So how we can incorporate renewable energy on site during construction phase. I know everyone is aware how to source renewable energy during operation, but yes, during construction stage, how do we harness renewable energy? So I'll be talking on that in a bit while. Apart from that, waste is the most important aspects which we have to look at. The quality of air which a person is staying on the site. So it's not just work, but the kind of air which is going in the construction, all the multiple stakeholders on site, the site engineers, the laborers, the workforce. So the quality of air which is being brought into their body, what is the quality of air? And health and well-being. So it's not only work, how we taking care of the health and the well-being also of the employees as well as the site workforce. That is also one aspect which I'm going to touch. And at the end, something which so Dhwani had described life cycle analysis during her presentation, so I'll be touching on the low carbon footprint and the recyclability of the materials as one of the topic. So coming to the first aspect is the materials. So a person, we when we are on site, we go for multiple times for material inspection. We go to the factory for checking the materials, what is the quality of the material and all. So yes, first thing is the quality and the desired specifications we require to meet. Yes, we put a tick box, but very few times if I'm looking at the material from the sustainability aspect or from the environment aspect, how local is the material, local in the sense how close it is to the construction site which is there. That is one aspect which should be added while assessing any materials which are there. Secondly, when we come down to what is the recycle content, so yes, so every new material which is dig up, it involves fresh energy. So the material when it reaches the site, before that, if I have to say, the origin of the material starts from extraction. To just give you a simple example, the aggregates which come, so the stone quarry, they do mines and explosions, so then it breaks down into boulders. The boulders are then again fined down into minor aggregates, shipped, transported to the site. Apart from that, the wood, the steel which is there, so whatever you throw it, so the steel, every time you're using steel, you are consuming more iron from the earth. So instead of using the virgin materials, why don't we recycle the extent, to the extent possible, materials? So though that is one aspect we need to take into mind while choosing the material which is there. And a very small aspect of the life cycle is the reusability and the life cycle of the material. Okay, so today you are using the material and tomorrow you are going to discard it. Just to give a very example, I don't know how many of you are aware about expanded polystyrene sheet which you usually use for roof insulation and all. So nothing happens to that material even during 20 years, 30 years down the line. So whenever a structure is being demolished, and the waste which is generating, they can be removed in a good fashion, in a very good shape, and can be reused as well. If we don't reuse it, it just gets dumped and goes to the landfill, where it creates a problem for us, and that's where the life cycle of the product gets hindered. Whereas the material is more or less durable and is good enough to be reused for another construction project with some minor treatment. So yes, reusability and life cycle of the material is also one of the aspect which should be there, in addition to the standard qualification of the material aspects which are there. uh, I've shown two certificates of materials which are there. So currently in India, so we have Green Pro, which is a body which is recognized, which is a certification branch of CII. So Green Pro usually evaluates all the construction materials, starting right from your bricks, cement, paint, steel, even your cleaning chemicals, all the insulation boards and all, they are all verified for as with the strict parameters with respect to environment. And the green parameters are given a certificate in the one you can see over here. So whenever the next time, whenever any person or any team member or any stakeholder is going for a selection of a material, make sure you pay attention to how green is the material. Is it classified as a green material by Green Pro or not? At times, yes, there might be some materials which may not. I understand that it becomes a practical problem at times to qualify, but yes, to the extent possible, whatever as engineers we can contribute to incorporate sustainability, we should do. So this is one aspect while choosing the materials which we can make. To give examples of some recycled materials, so the recycled steel which is there, so 20 to 40% of recycled steel is reutilized currently nowadays in almost all the factories, because yes, for the manufacturers it is bonus, so that it costs less, and the extraction of virgin materials is minimum, so its impact for the environment is minimum, so it's win-win for both. In concrete, by default, you must be knowing that concrete as well as the cement, we use fly ash instead of calcium, so that also creates an impact. So it reduces the extraction of calcium which is there, and also it reutilizes the waste products of fly ash which is there. The tiles which are made, they also contain recycled in the means of 10 to 25%. Glass, is almost recyclable up to 100% extent. So if it's clear glass, yes, 100%. But when you go for colored glass, yes, there are some limitations with respect to recycling, is in the color, so exact color and type. But yes, glass is almost 100% recyclable. I'll be trying to address this in the waste management. How do we take care of it? On-site design, there are multiple on-site design parameters. I'm just touching upon 2 to 3 aspects just to give you a flavor about what are the things which we should look at. So yes, during the construction phase, the water from the site, especially during the monsoon season, the runoff is very high, and in the and the topsoil is usually the one which is the most affected by that. So incorporation of a silt trap basin in the design, so it at least helps to arrest the topsoil to a considerable extent, which is there. And apart from that, the topsoil which are by default we are using, we can just stockpile it up to a certain extent on the site. The topsoil, the reason for the topsoil is it is the most fertile soil in the entire land, because it contains minerals in the highest proportion. So we need to stockpile that, cover it with tarpaulin or polythene sheets, and save it for later use during the project execution. Coming to solar installations and also the practical problem which we always face on the site is that at times we see that the solar panels are just placed for the environment compliance sake, or just because the client has said he wants to install solar, they install it. They don't look at what angle they are inclined to. Are they what is there any shadow coming up from the OHT tank or from nearby structure? So those are the principal aspects and on-site factors which one should look at while installation of solar panel. The same goes for a solar hot water system also. So just for your knowledge, so the inclination of the angle is equal to the latitude of the place. So Mumbai is in 19-degree latitude. So ideally, the solar panels are inclined at 19 degrees from the flat surface, with a plus minus 5 top and the bottom for the summer and the winter adjustment. But yes, the point which I want to highlight is that shadows which usually, so one should install the solar panels after evaluating the shadows. You must have seen a lot of solar panels on the street lights, they are covered with tree shades and not cleaned properly. So actually that's a wastage of resources and not proper utilization of the renewable energy which is there. Even the same thing, so during a construction phase, we can try to identify spots on the project area where sufficient sunlight is coming throughout the day, where there is no disturbance from the shadow, maybe the temporary storage yard or so, and we can use the solar panels at least to make sure that the lighting load on the construction site is met. So those are the some aspects which a civil engineer or site engineer can look into, which is there. Secondly, services routing. So I don't know how many of you have experienced this problem, but wherever solar is installed on the roof, routing of the services becomes a big menace because proper planning is not done. So please, whenever we are getting into the design aspect, please plan the services and the renewable energy installation together, so that the services can be aligned properly, which is there. Coming to the environmental factors from on-site, so yes, so whatever materials which we are choosing, should we have to ensure that the composition of the material is good enough. There are no deteriorating products. So you can see the image of the asbestos which is there. Asbestos, though it's not allowed because it has it causes respiratory disorders, but in India there is not complete ban on the asbestos, definitely due to the social economic problem which is there. So the lower income group, they especially work in factories where asbestos is a great hazard. But we as a responsible engineers and we have to ensure that no asbestos products are being used for construction. Apart from that, what are the physical properties of a materials which we have to look into? So whenever we are choosing any physical property, like so just to give an examples, AAC blocks are much superior compared to a brick which is there. They provide better acoustic and thermal properties compared to a brick. Similarly, there may be other materials available in the market which are at par with compared to conventional products. So that change or the shift of material or selection of proper materials is required. No wonder it also reduces the dead load of a structure, and ultimately it helps in reducing steel, and thereby it also adds to some level of sustainability in the project which is there. Leakages, so during construction we know that water leakages happen. So though the leakages menu is just minor, but multiple leakages and just summing up that leakages through the entire site, the water loss is tremendous in terms of KLD. We need to try to address this such small issues on site, so that wastage of natural resources happens to a minimum. And thereby, okay, you are, as a site engineer, you are trying to achieve sustainability in one way or the other, which is there. Contamination is one more problem, in the sense that DG said, so oil spilling which is happening. So the oil which penetrates the soil beneath there, usually when we have the on-site mixtures and the diesel generator sets, there is a very high tendency that the oil may get spilled over in the soil and the nearby areas. So we have to ensure that they are properly lined with the polythene sheets, or some kind of a membrane which separates the ground from the machines and the oil spillage. Recycling is one aspect which we have to look at. So whenever we are doing, so the waste utilize steel or any wastage pipes, try to utilize in the maximum extent to the negative spaces inside the space which are not predated, but so you can construct some drain gutters out of that small steel pieces which are there. Use the pipes for conduits in the beams as such. So those are multiple ways which we need to, I'm sure many of them must be processing. As I told you, these are just very key, just I'm just touching very superficial information which is there. Waste management, the most important aspect from sustainability on the site. Materials, whenever they are brought in fresh from the factory, they have a value very high associated with them, and hence we tend to keep them in a proper fashion on site. But the moment a waste is generated, we try to throw it haphazard on the site because it has no value. In fact, that is also gold for you in one way or the other. So proper segregation of the waste is the first step which we should align on site, say a material wise, and thereafter we need to classify them into proper materials which are recyclable, reusable. So, and tie up with the relevant agencies who are into the recycling and the reusable business. So mostly metal, plastic, glass, paper, rubber, they are often recyclable. It's so from a site engineer's perspective, it's just the connect with the correct recycler which is required. It's just a very small tab, but yes, that gap has to be brought down. At times, due to lethargy and other factor, other social factors, we, this is just a waste, we'll just try call the dumper, he will collect it and dump it. But a very minor effort in terms of connecting with the right agencies, they will come to the site and they'll just collect. And yes, you do get revenue out of the waste also nowadays. So to just give you a fact value, so 1 kg of plastic costs INR 15 per kg. Previous 2 years, we used to just dispose the plastic bottles. Now you see the rack because collecting the bottles even from the roads, from the railway tracks and on. So yes, the moment you assign a value to a waste, it gets a value. So that is the whole fact, that is the mind shift which is happening across the industry, where waste is viewed as a value. And that definitely, that step is helping everyone to minimize the waste reduction which is there. Hazardous waste, as I told you, oil, petrol, diesel, we need to store them properly, ensure that they are not wasted, and if there is any leakage, proper association is proper measures are taken to remediate that. Tie up with pollution control bodies, registered pollution control bodies, who are responsible for collecting the waste and recycling them or refiltering them. If you are selling it to any local vendor, he is just going to spill somewhere on the land or the water or any other else where it is just going to result in pollution. E-waste disposal, though no, not a big problem on site, but yes, so nowadays with this expanse of site getting into acres, and also the number of computers and everything which is going on the site, a large amount of e-waste is getting. So we need to tie up with the regular agencies who are into it. By the way, from the e-waste, so the materials which goes in the electrics are usually the gold, silver, and the platinum, palladium. So those are the materials which go into the manufacturing of electric circuits and all. So yes, it is actually value for the diggers who are there. And at the worst case scenario, when you are able to do nothing with that waste, that is the time when it has to go to the landfill, and that proportion needs to be minimum to the extent possible which is there. uh, One more key aspect of sustainability, so it's not only conservation but also health and well-being of an individual, as well as safety. These are also one of the most important aspects of sustainability. So only if a person is safe and well will he be able to work and contribute his wit to the work as well as the environment. So safety, I'm sure every at every organization, safety is taken with utmost care and importance. So we have to ensure that that is followed, and utmost importance in terms of reporting, and any kind of accidents, it should be taken on a serious note, and steps to be ensured that it doesn't occur frequently or never is the word. So the images which I've showed is the one is from an MMRDA site, MMRDA metro site, where they do practice some exam. They give us around 15 to 20 minutes of timing for physical fitness every day. So this ensures that the people who are working throughout the day are fit, and so they tend to give better output. They are more alert during the work, lesser absenteeism, lesser fatigue, which is there. This can be inherited as a daily exercise as well, in any organization, wherever you're working. You can definitely insist for doing that. So just to give a fun fact about here is that you generate more calories when you are standing, rather than the sitting. So for the site engineers who are continuously standing, yes, you definitely burn more calories, but that doesn't mean that you stand all the time. Yes, take proper rest at after every intervals to reduce the fatigue, and thereafter continue the work. But definitely when you're working, yes, standing burns more calories than sitting, just for the fact which is there. Coming to the last aspect, which is there. So the table which is, the color code which I have, the pyramid which I have showed, the half pyramid which is there. So yes, the level of awareness, we know that the site workforce, who are the ground people who are working on the site, we know that their level of awareness compared to any stakeholders like the architect or the engineer, or the MEP consultants, comparatively low. So a lot of effort has to be given in that particular area, where we educate the workforce how to do and why to do. I think whenever a human understands why are we doing it, or why is he doing it, we definitely give more. He understands it better, and he tries to comply it, because before that, so just to give a very raw examples, I see whenever you go on construction and you see the pieces of that tambaku or pan masala just lying on the floors, and it gets into the concrete. So when you open the concrete shuttering, you see those pieces just stuck over there, which is there. Whereas on the contrary, when we educate him about what is the plastic, or at least he should segregate, throw it in a designated place, so that gives you better quality of work, and well as increased awareness among the people. So starting from site workforce up to the superiors, the engineers, so the level of awareness which we have to imbibe in the site workforce is the highest. Whereas when the supervisors, engineers, managers, yes, they do have some level of awareness, but it has to be brought into action, which is there. uh, I think I tried to keep it very simple. So please shoot any questions, please give any suggestions which are there. All open to you guys.
Yeah.
Over to you, Mr. Kulkarni.
Palasha, you can take two
Quite a
questions.
lot of, yeah, there are some questions that are coming from the audience also.
Yes.
Then few of them we can keep at the end, but at least immediately we can take two questions.
Yes, please.
Yeah, so Mr. Sahil has particularly asked, like, what are the steps taken by IGBC to promote green building? And further, do we get any kind of subsidies when, probably as you said, after this ESG reporting, like if we are compliant to some, say like GRISB, so are there any benefits that financial benefits particularly, apart from the environmental benefits that we are giving? So, can you?
Sure. Yes. So the short answer is yes, at least when it comes to Indian government. For that matter, every state government has drafted out incentives, and there are various incentives in terms of FSI, in terms of the built-up area, in terms of what you can do with your asset, etc., your taxes, etc. Every state has a different drafted policy around it, but the short answer is yes. There are incentives and there are subsidiaries given by state governments. I hope that answers the question, or was there something else?
Yeah, so that's quite a.
Sure.
Yeah, Jayan sir, you're having some questions. So let's, yeah, I guess so. We move to the next session.
Sir, thank you, Parashar.
Thank you
Yeah,
so
thank
much,
you, Dhvani.
Dhvani.
Thank
Thank
you.
you so much, Vivek. I mean, one can talk for so much time on what you have given us. You gave us the larger picture. You gave us the nitty-gritties. You gave us how what it is to start a building which you want to be environment friendly, and you also told us how it can be implemented. And I think half an hour, I know it's not enough, but it was inspiring. And I must say that each one of us who's listening wants to do something in this field, definitely. Moving on next to the next speaker, ladies and gentlemen, it's my pleasure to introduce engineer Ajit Pulkarni, who will be talking on again an interesting topic, rediscovering the future of MEP services. To introduce Ajit sir, he's been working as a consultant for IT offices, banks, and numerous kind of projects in the multiple fields of electric, fire, security, energy audit, and so on and so forth. And I think at this stage in which we are in the webinar, we are just warming up. Firstly, this is part one. And we saw from what Dhwani and Vivek told us about the relevance of this to our day-to-day lives and on the global scenario both. So I feel it is logical that now we hear from engineer Ajit Kulkarni on rediscovering the future, as in looking into the future of where MEP services stand or their role in environment protection. Over to you, Ajit sir.
Dear friends, good evening. Welcome all to this workshop. Thanks for introduction. Thanks for Epicon for arranging such brainstorming workshop. Epicon always, arranges the workshop which are with the latest trend setting. And the topic of today is of the thing beyond the green is actually need of the hour. Although a lot of theory has been already been told by Dhwani as well as the construction point of view, Vivek has already touched on to it. We have got always challenges which we have to meet for the rules which have been given to us by the green and other wellness and other certification. And also there is another challenge of time, cost, client's aspiration, and so many things. However, as an electrical point of view, or the MEP perspective point of view, or the HVAC point of view, if you want to see, then in that case, those challenges are always being taken by the engineers. Actually, I have made this presentation in line with Beyond Green. So few slides could be in the range, what you call as something which is sharing up with reference to covering all the matters which have been covered under the green. However, those slides, we will skip it out. Now, considering the fact that of Albert Einstein, what we have mentioned once, that once we accept our limits, we go beyond them. So it means that if we want to go beyond green, then we have to first identify what is green from the engineer's perspective, then understand the green limit, and then subsequently go beyond the green. So as we know that, let me quickly say about the green something, that in the topic of green, then this initiative was started by the LED. If we want to achieve, then credit points are there, 40, 49, silver 50, 59, gold 60, 79, platinum 80 point. Then we must have the certain criteria, that the location and the transportation, material and resources, water efficiency, energy and atmosphere, sustainable site, indoor environment quality, innovation, and a regional policy. What we actually get is something good for the human kind, that we get a CO2 emission which is 34% less approximately. The energy consumption is nearly 25% less. What all consumed is 11% less. And we get a healthy atmosphere, efficient facility, cost saving proposition, and many more. So it is not only the lead, which is the certificate, what we are going to get it, but what we are going to the humankind, the necessity, the requirements, which is there. As Dhani has already mentioned in by large, the green means focuses on to the environment sustainability. It means that preservation of the natural resources. So in the sense of design, construction and operation, there could not be any impact onto the natural environment. As a designer, I have to see so that land, water, air, climate, plants, animals, etc. will not get suffered. So in short, the MEP perspective, MEP viewpoint of air, water, gases, lands are many points which are the main point which has to be looked upon. Now, along with the green, there are so many confusion which happens in the general person that sustainability, carbon footprint and efficiency, where it is. So sustainability is nothing but to reduce the environmental impact, human health factor. You have to consider the natural product of the energy which will not harm the environment, use the energy that can use the continue forever and not to disturb the natural resources, which is important. The carbon footprint point of view, amount of the greenhouse gases such as carbon dioxide, methane, etc., which we are releasing into the atmosphere while designing. Also, we use the CFC and all that thing, which is very much harmful. And from the efficiency perspective, we have to make sure that the efficiency has to be very good rather to maintain this lead perspective. Hope I think we are, I am audible and all the slides are getting through, right?
Yes, sir.
Yeah, thank you very much. Efficiency, when we are talking about, means it is related to the energy which should be always high. What are the energy? Because when we are going on to the site from theory to practice, then in that case, we are going to play with the energy. So that is potential energy, chemical, nuclear energy, stored mechanical, gravitational, radiant, thermal motion, sound and electrical. And by improving the efficiency, what is going to happen is, what we are going to achieve is, then in that case, we are going to achieve the reduction into the climate change. We're going to the less pollution, less energy cost for the consumer, because as soon as you go into the less energy, means your consumer cost will go down. In fact, while on the subject, the solar energy, which was costing something like 10 rupees per unit, now it has gone to nearly 2 rupees per unit. After the having this Badla plant, they have made at Rajasthan. We improve the competitiveness of the business. You can get a net zero emission of the carbon dioxide, and one can get a cleaner air. So therefore, we have to little bit redefine this green while designing and construction and operation. Is that one is that improve the energy efficiency. There has to be some sort of an environmental sustainability. There should be preservation of the natural resources. The minimum impact should be there onto the land, water, air, climate, plant. Human health factor we have to consider. Natural products and energy which will not harm the environment. And then use the energy that can use the continue forever to be continued for the long time. Reduce the use of green gases which will affect the human being. Now we have got lot many technologies which are there, and we are implementing that also. But to cover all this point and club into the half an hour from the MEP perspective is very difficult. And it's a very really Herculean task. But allow me to touch upon some new trends which are happening, since we are touching upon the green, beyond the green. Therefore, I would like rather to touch upon the new things which are happening or which are not happening, but which we will implement. And then what are the developments which are happening in future into the sector that I would like to touch upon. So that will become an interactive session also. It will be interested for all, because all the people are knowing about, all we are knowing about the rainwater harvesting and solar and wind and etc. But there are something else is also there which we must now look after, because of the new era in which we are going into that. And there are certain available technology, but still we are not practicing fully. We are not practicing this 100% like rainwater harvesting. the rainwater collection peak and then using for flushing. We are taking out the excuse where I will take the rainwater. But we have done various projects wherein we have collected into the tanks and then used for the flushing. And in normal circumstances, it will be closed and will be bringing the water in from the external tanker. So you can reduce some sort of a water involvement into that. Whatever the STP, we always talk about that to have the output water for gardening and chillers. For years, we are listening this theory is knowing to us, but really question is whether we are implementing that. Let us, I think, as an engineer and architects and practitioner, we have to put it into the practice and insist on the client. Let at initial stage the costs go high, but it will be from the environment perspective, it will be very much useful in future. The heat recovery from the fresh air. This is another topic. It's a very small thing which is there, but whatever the fresh air which we are bringing in from the HVAC point of view, if we have got the heat recovery, it means cool recovery basically. The air which is coming in can be reduced down, and I can show the n number of projects wherein this being not implemented because of the cost. I think at this time, as a responsible person, we have to put it to the client that to use such things. Then there is a TFA which is there. Again, same thing is happening. Whatever the fresh air which is coming up, we are not using for the treatment of HVAC. Because if the air which is coming up, if it is treated, then in that case, what is going to happen? The pollution will not come in. People will be happy for that, and the HVAC temperature will also, the tonnage will get reduced down, and the net effect of the carbon will get reduced down. The coolant tower, water we are either circulating or wasting, but we have done certain projects in Mumbai where it has been used for the AHU or the air-cooled machines, and then utilize that air, the water which has come down from the cooling tower temperature. Similarly, for the power monitoring, we have got the software readily available, but the implementation is not happening. Then the Novec gas, as all of you are knowing about it, that is instead of FM200, which is CFC related, but Novec is a clean gas, and therefore by using that, we can use the carbon footprint and ozone depletion. Then there is another topic of discussion of the fabric ducting. The GI ducting versus the fabric ducting, which is the new technology which is coming up. At certain time and certain location, we can definitely try and use it wherever, let it be at a warehouse or be at somewhere at exhibition hall. Then VABs which are there for the motors, in small motors, if we put it, then there is a lot of saving which can happen, and still we are apprehension of using that. The power factor in electricity industry is another topic which is to be discussed in length. You can have at least a one day on to this power factor and harmonics business. But this is also an improvement has to be done so that your energy consumption will get reduced down. And this widely discussed topic, that solar water, solar panel, wind generation, and we can definitely use that, and we can try to utilize that whatever the extra galleries we have got, or whatever the ceiling which we have got, terraces which we have got, and onto the roof of the industry, and we can reduce down. I have got the examples wherever it has been installed and which we have implemented, wherein in case of one factory, there is no electricity, zero electricity being used, and entire power is coming through the solar panels. So coming to this cogeneration, I think all are aware of this, so I am not touching into this topic over here now. And also the UPS. UPS is going to be the big guzzler nowadays because of the data centers which are coming up. And they are in very heavily power guzzlers. So over there, these UPS of higher capacity, if we can go with the lesser footprint of the UPS, possibly we can able to reduce the footprint. Once we reduce the footprint, then in that case, what is going to happen is we can have the available area, lease area can be get reduced. Now, how to improve this efficiency is a big chapter, because when we talk about the energy, then in that case, we have got to be improve upon. Now this energy, any energy if you take, and in which if we want to discuss about the efficiency, then in that case we can improve upon, but first is recording. So recording means measure and record the reading, then analyze it. So while doing the analyzing, we can have the usage pattern, the energy utilization, targets, output, benchmark, and then what is the sanction which is there. Then we can keep a target setting onto that. Controlling means measures to be taken for the calculate implementation and then keep the check of the it. And we can monitor that. So monitor is the also another target which can meeting or not. If there is any correction is required in certain field, if there is a reset has to be target is to be done, whether we have to do re-monitoring, and then subsequently the reporting, whether we are going in line or not. See, whenever we want to do any energy efficiency, let it be thermal energy, let it be nuclear energy, wind energy, or solar energy, by just putting certain energy or cogeneration plant, it doesn't mean that, okay, I have achieved something, I am happy over here. But really how much energy, whether we are going to have saving into that, is it becoming very useful or not? How much efficiency into that which is sufficing? That also we have to see. Otherwise, many of the times we put a wind energy and subsequently we land into that some of the 5 or 10% which is going into creating that equipment also, and also the material which has been used over there. So therefore, efficiency is one part which I would like to touch upon. And before going into that, I would like to go into the few terminologies. Now, efficiency, when we say it is a motor efficiency, if we consider, then in that case, it can be a 70% or 95%. Now, this efficiency is suppose 70%, then electrical power will be drawn by 107 kilowatt. Before coming to this slide, I would touch upon these 2-3 lines over here for beneficial for all the participants. Whereas when your efficiency is 95%, then the electrical power gets reduced down to the 79%, so direct reduction of 20%. So do you mean to say, should we start changing the motors, sending the machines? No, not at all. Wherever it is possible, we should replace it. But if it is a new thing, then definitely we can think upon it, how we can do this efficiency improvement into that. Now at main thing which is happening is, we have to think in different way, because we are into the area and era of the digitalization. So can we make this efficiency related business, which is there, instead of writing and making onto the platform and then dependent upon the human technology, can we do something over here? And therefore, this is the new thing which we can definitely come up. And for that, some initial few slides, I will go through that. Somebody will be knowing about this, somebody may not be knowing about it. That embedded technology. So this embedded technology is nothing but a hardware having a software embedded into the machine. So it is a microprocessor based system which is designed to perform a specific task. You have got any machine, say for chiller or say for electrical, any motor which is there or transformer is there, or any other machine in which there is a hardware, it will be embedded, and that hardware will be doing the analysis of that and will be giving the specific task as decided into that. There's another thing which is correlated into that is artificial intelligence. As we know, artificial intelligence in the computer system tries to think as a human intelligence. It's a parallel to the human intelligence. Definitely, it cannot beat over there to human intelligence, but there are certain algorithms which are there. They are not programs, and they have got algorithms corrections which they work it out, and with own intelligence they do it. Something like Alexa of the Amazon, which is there on Amazon, which we see, or the self-driving vehicles which are there. So that is what which is there. Now, third chapter, or third point, which is there is a ML. It's a machine learning computer. It means that machine learning computer means predicts or the take decisions using the historical data with less programming. Means ML works on the algorithm also, and they formulate their own historical. Once they have been given their own algorithm, they worked out on their own data, and by go empirical data which is given it to them, or the historical data which has been given. So if you want to give a large quantity of the data, then it can check very quickly themselves and they can improve upon themselves, and with which you get a better result. That is what machine language which we are talking about. So there are various machines which are there. They collect that. This machine language can analyze that, and after analyzing at human level, they can give the decisions. Okay, boss, you can do this way. And now this is a buzzword of the IoT. That is the Internet of the Things. The Internet of the Thing is nothing but a physical object or the devices that can be said as a things. Means what you call as a temperature sensor. You can call it as a thing. Or what you call as a humidity sensor. You can call it as a thing. So those sensors or those objects, they are connected to the sensors, softwares, and technology which are embedded into that. And they can connect and exchange the data with each other devices and system over the internet. So while doing the IoT business, all these things, the small things which are there, means you consider, say, suppose in diesel generator set, there is some oil thing is there, oil level. Then there is some cooling water is there, cooling tower is there, there water is there. There is a LED lighting, there is some sensor is there. But the platform is such that all these sensors, breadth and width, top and bottom, they talk with each other with their software technologies, and also throwing that data to their software as required from them. So this has got a, what you called as there is no limit from household to anything, something like a rocket. This can go into the IoT. And therefore, this new trend which has come up, that is Industry 4.0. So on this Industry 4.0, this is a revolutionary thing which is going to happen. And the Industry 4.0, the background is that Industry 1.0 was something like steam use. Then 2.0 was a mass manufacturing. And third one was the electronics, computers were there. And now the fourth one which is there, that further digitalization has happened. And all these above parameters are fixed together, and which has come into the things, and we have gone to the Industry 4.0 level. So what that can do? It can do upon the energy management, it can do the meter management data, you can have the fire survival, security, etc. also on, along with this, the above. You can have the utility supply, transformer, DG, UPS, HVAC, etc. Further to this, they will be having the preventive health of the machine. Further to that, there will be a remote building management. The transportation will be taken care. Then the water management will be taken care. The efficiency in the machines will be done over here. The asset management and carbon footprints will be done, and there are many more. So this technique can be used as an IoT-based BMS into the MEP, and with which the BMS, we can integrate all the requirements which are there, all our gadgets over there at site. And then we can get more and more efficient these machines out of it. As I already said to you, we were at 70% once upon a time. Subsequent to that, we have improved to say 80%. So 10% improvement is there. But now we have to go towards the 99% possible. Then only our energy is going to reduce down unless you change certain technology into this. So this is a very basic building management system which we are doing, not compulsorily, but sometimes. There is wherein there is a electrical system is there, temperature is there, humidity issue is there, chiller age, AC machines are there, ventilation, UPS, DG, meters, and lighting. This is the absolute BMS machine. So one can see the PC over here, there is the software over here. All these AHUs, FCU, chiller, HRW, VAV, energy meter, breaker, UPS are being controlled on IT BM backbone. And we are getting, this is the traditional structure we are getting into this. But there is no, what you call it, further data, what we really intend to get so as to achieve the energy efficiency. So subsequent to this, there was some sort of a thing which has happened, that is the industrial sort of a business architecture which has come. So along with the data which we were having, then in that case, we have clubbed the third party integration. This is the third party which is there. All this data which was there. Now into that, we have added some sort of a additional unit like scrubber unit, or we can call it a lifts, or we have added water treatment and STP. So this is absolutely at industry level. It's not something we have done great. But we have added the third party gateway in which we have got all these panels and other things which are there. These are some indicative, but anything which can be as a third party can be added into this. So with which we have arrived to some PMS, which is a higher technology. And over here, again, the further advantages which we wanted, we were not getting, that we intend to get in the future technology, which is the industry 4.0, which is yet to come into the market, and which will be the future. So what we get over here, this equipment can be monitored finally. You can have the operations verified minutely. Performance can be checked and monitored. Data can be used for the predictive maintenance and performance. Now, this is a very important thing which is there, that there are certain things we always provide. Okay, I have provided fire pump. But unfortunately, during the last fire which has happened in Mumbai, the fire pump itself was not working. See, this is very sad story. We talk about lot many things, standard and all that thing, but when it comes to the ground reality, it doesn't work. We talk about STP. Okay, I want this STP and the output has to be connected for the chiller and etc. But really whether it is working, whether really the material is there, what is the output, what is the yield over there. So that is not being given. At any given time, if the shaft breaks, then in that motor will not function and you are not getting things. So that's a predictive maintenance which you can get it. Then there is another thing which is there is an asset life and a value to be checked. You have got a lot of assets, many assets, the crore rupees of assets which are there, billion rupees of assets. There are so many solar panels are there. Where are they now? What is their individual condition? What is their value? And whether they are functioning or not, that is where we want to now check up. Another thing is that we have got energy conservation, that we talk about a lot of energy conservation and energy conservation. But whatever the targets which we are getting, are we meeting that? At ground level, if we say, the answer could be many of the cases or no. And then subsequently we again revisit and etc. But if we set target over here onto the machine, right from the top to bottom, from management to the small electrician, will be knowing what is my energy requirement, how much I am doing daily, hourly, and per minute. So also we can go with the optimization targets. See, as Downey is there from the CBRE, which they are doing from the facility management perspective. They have got targets. These facility people have got targets. They have to reduce down the energy 1%. For them, such type of things will be useful. Operating can be cost reduced, can be reduced, because functions can be optimized. There are a lot of interrelated functions which are there. And those interconnected functions can be optimized. Okay, after doing this one, I have to go to item number 2 and then item number 3. If suppose in the design sequence that has been given, but at site, the thing is different, then automatically you can change the sequence of the operation, which I will touch upon when I will come into the next slide. Now, because of the integration of the multiple mechanical, electrical, and plumbing system together, the total system is getting integrated. This was the one of the point which Downey has brought in. We have to see the total integration. As an electrical engineer and electrical site engineer, he will look upon the only electrical system. As an HVAC system, he will be looking the HVAC system. As far as the plumbing and the sanitization is concerned and the construction management, they will respectively see their systems. But whether all these systems are talking to each other, then in that case, individually, no. We have to bring these all systems in totality on one platform so that they are talking and we have got a control onto them. We are getting report of that. Efficiency will increase. That's the main motto. Facility team can take decision in advance for outages and minimum breakdown. This is what minimize the breakdown. This is what I have said upon. Many of the times at urgently, we have to take certain decisions. And IT people or client doesn't give the breakdown. At that time, we have to take the decisions, and that early decisions which are there and the downtime reduction which is there and the loss of revenue which is happening can be done with reference to this. There's a ease in commissioning, and therefore it is the overall efficiency of the organization. So this is where we are. I will not go much into the technicality as it is. I know because there are a lot of architects are there, structural consultants, PMCs are there. But for all of them, it is necessary to understand this is the small level of what we call as a site level, or you can say as a site level sort of a thing, wherein all the MEP related equipments are there, be it DG or be it HVAC, chiller, etc., etc. So that is called as a third party, and that is called as a field level. The second level is called as a management level. So wherein there are various softwares are there, and all these third parties which are there, they are integrated with each other. Now BMS has got their own function. EPMS means Electrical Power Management System has got its own system. This DCI, Data Center Management System, will have their own software. Now all this software will start collecting the data at the field level first, then they will talk with each other, and overall they will give the BMS system. And not only that, further they will be connected onto the cloud, and therefore this IoT as a managed service will be available at cloud. So at cloud, by doing this, what you are going to achieve. At IoT level, if we say we have got a 3 digital integration, as I said to you, there is from apps we can connect, from the projects we can, what are the project data which is there, that will be, secondly will be the OT approach. The first one was the IT approach, then OT approach, that is control and the connected part. And then the vision, which is IoT wants. They will collect all this data, which was given onto the client, onto the cloud, to the client. So it will work onto the customer related. You have got a remote sensing, you have got a report generation, service provider customer views, maintenance performance. So you get a monitor, detect, diagnose, and identify the energy saving. Now what you get in nutshell, if you see the last column, so outcome is nearly 33% reduction is there. This has been analyzed worldwide at few sections. 20% reduction will be there in the complaints. You have got reduced the energy of 29%, and 80% will be the problems which will be resolved remotely, which were not being done up till now. How it will happen is that it will be monitored. The analytics which will be built in by any organization will do the analysis the report and collaboration will be done. The remote support which will be there will be available to anyone. And then on-site management is there. So it is a machine-to-machine talking, machine to human talking, human to human talking, and human to machine talking. So all these platforms are at one side. Do you mean to say, are we going to eliminate the human intelligence? Absolutely no. We are going to utilize the human brain very efficiently, but we are making all these machines to work. Up till now, we were working for them. Now we'll ask them to work for us and give the respective data so that we can get an increased occupant comfort, reduce the operating cost, and improve the asset value. Sorry. We were over here. So in nutshell, we are going to get nearly 29% schedule maintenance, 20% energy cost, 33% into the occupant complaint, and 80% into the things. Now, this time and this era is a global village, we call it as. So somebody is sitting at the US, somebody is sitting in Singapore, somebody in India, somebody is somewhere else. The management could be different. Somebody is talking to their management at Bangalore from the Boston, as Obama has mentioned. So everyone must be aware what is going on at every site. So being at the secure cloud with the security which is available, and through all the gateways, what we are going to collect, the desk occupancy, ceiling occupancy, air quality, people count, people flow count, all these will be available onto the universal platform. So any decision at any level can be taken. There is no necessity of taking decision. This is the available thing. Whatever the data which you want to get available out of it, any organization can do that. And subsequent to this, we can make it available. So this is as far as IoT is concerned. I think I will now little bit shift to the upcoming into the lighting management system. Once we say the lighting,
go, sir.
How many?
5 minutes to go.
Oh, my dear friend, sorry. Then I think I may have to wrap up like anything. So this is a new lighting management system. So wherein we have got a energy saving, we have got a daylight harvesting, color changing, visual comfort, dimming, scene selection, human centric, asset tracking, and space utilization. So what we are going to get it out of is this, that lighting management, we can get a central control panel, scheduling, light control API, lighting asset management, maintenance information. You can get alarms, automatic notification, automated emergency testing. You can get an energy optimization by the lighting behavior, daylight harvesting, energy dashboard, energy analytics. All these I can take up onto your next question answer. Scene management we can do with this energy management. The space management, this is a new trend wherein hot desking is there. You need not have one particular cabin or one particular desk which is happening. You can select, and for that you have got this software which is available to you. You have got indoor navigations which are there. So wherein anyone can sit into this. Then there is a bioadaptive light. This is a tunable, that is a tunable white light with the program which is there, so that everyone become efficient. Environmental monitoring and temperature, humidity, and all that things can be getting into this. So there are intelligent sensors into the light fitting which is there. These sensors are bundled into the advanced sensing platform. We are going to get, as I mentioned to you, the room temperature, occupancy detection, relative humidity, daylight measurement, desk occupancy, people count, temperature, high temperature, noise level, indoor positioning, and navigation. This is the platform again for the lighting management system. I will not go into technicality of this. Now, May I request to give me 5-10 minutes more, Jain Pulkarni or architects, Gokhale, please.
I think we can give 5 minutes, there is no issue. But still, if you limit to 5 minutes, it will be better.
Okay, anyway, thank you for that. Safer and more productive environment. This is our thing which is there, which we can get it from here. We can get the improved staff efficiency, which is there. Minimize the energy consumption, which is there. Now, this 5 minutes, which I wanted for the HVAC consumption, is HVAC consume nearly 71%, and it's a big guzzler for in our industry. So out of that, we can get VRV, which has got a less tonnage kilowatt per ton, as I mentioned over here. So we may opt for it, or whenever chiller are there, we can go with the water cooled chiller. Now we can also obtain further HVAC efficiency, insulated walls and ceiling, reduce heat generation from lighting, design spaces we can do. We can do avoid the losses through the leakages. We can do the double glazing, so under less emissivity windows. We can use the blinds. Temperature can be increased little bit to 24 degrees. We can go with the operating times, so that whenever the people are going to come, at that time only we start the chiller. The ventilation system can be optimized. The variable speed drives of the AHUs can be used. VAVs will be there. Ducting work can be done properly. Proper insulation can be done, so less tonnage will be there, and fresh air will be there with CO2 sensor. Fresh air, as I mentioned to you, for that with the TFA. In data center, the load correctness can be reduced for the AC capacity. The hot aisle, cold aisle, things can be used. The insulation of the wall, floor, etc. can be done for the sizing. Reduction of the data center size can be done, so that downtown of the HVAC thing, and shading factor outside facade can be used. This is a new thing which I will just take 1 minute. This is a new, means absolutely new, 202.22, it has been introduced. All the people who are using into the chiller, they can put into the service. This is the 1 to 5-star system, which has been brought in by India Cooling Action Plan. So whenever you are going with chiller and ordering with the chiller, ensure that you are getting a star mark chiller, so that you can get a high efficiency, less kilowatt. Now this is the new trend, that's the energy efficient motors. Now in energy efficiency, nearly 50% energy is the electrical motor. If we can use the energy efficient motor, you can drastically save the efficiency. Consider out of 50% of the electrical energy is used onto the motor. If you can reduce down to 70 to 80%, which was there, to then another say 5 to 15%, then in that case, we can achieve a lot of into this. There is a new thing, which is, as you are aware of that BEAM, it's a business information modeling, which is now getting up in this architecture, structural, HVAC, electrical plumbing are coordinated. Clashes are found, and this BEAM is widely used. This is a new trend. The virtual reality is another new trend, wherein the entertainment and only the presentation which were happening, but now in engineering MEP field, it is coming up, so that you can get at site what is happening over here. In drawing, by sitting into the office, you know what is happening, what is the correction level you are happening, any problems which are there, you can able to resolve it, and how a look and feel can be done. Then building scanner and laser based, this is a new thing which is coming up, which will come in future. These scanners will be located into the building. They will take the real inputs where the drawings are not there. They will collect the information and prepare the model for you. So therefore, you have got the drawing which is available to you, and if you want to do the modification, you are having this. So concluding remark, energy is a major input for this economic and development for any of the country, and energy is required. Hence, in any case, energy sector is very vital. Today's luxury will become the necessity for tomorrow. Once upon a time, freeze was a luxury, now it is a necessity. What is in our hand is to increase the efficiency and technology to be used for the same. Surely, we have the responsibility to leave for the future generation a planet that is healthy and habitual for all species. This is what Sir David Attenborough has said. we have to strive for his word. Also, that it has been said by Mahatma Gandhi. And thank you very much. Thank you, Epicons. Thanks for listening. Thank you.
Thank you very much, Ajit sir. That was truly a lot of new things we learned. Some old things were re-emphasized. And on that note, I hand over to Parashar before we move on for probability of any Q&A.
Yeah, I guess so. There are some questions that are popping up. So like Mr. Qaish Desai, he has asked us, implementing a sustainability plan is just the first step. One needs to show positive differences made into the action plan. So could you suggest methods for measuring this progress? Ajit sir, basically, I guess so this question is to you, like, what are the maintenance aspects? How will it affect the performance?
Yeah.
Does it affect the operational expenses? Kind of.
Yeah, right. So this answer is very broad, but at the same time, see, once your sustainability comes, your carbon footprint is coming down with the CO2 sensors which are there. Therefore, what is happening is you are getting a better feeling into the office, your efficiency increases. By using the non-carbofluoride gases into our industry, like what we use in a separation system, then in that case, you are getting definitely a good gas into that. So your carbon dioxide limit is going into that. In operation point of view, you are reducing the efficiency. So ultimately, you are getting the definitely better benefit out of it.
Okay, I guess so that has answered that question. Yeah, I guess so. We let me see some more questions for this. Okay, I guess so. We should move to the next part. Priya?
Friends, we've had an exciting session so far, but on this note, it is important to acknowledge the support of organizations and companies because of whose support and encouragement such initiatives can happen. So on this note, I would like to acknowledge the support of Nagarjun Construction Company Limited, and I love their tagline, which is crossing all milestones, generating legacies. Friends, let us get to know a little about this company. I request Vihar to start this presentation.
At the heart of NCC is a similar passion to do the new, to make an everlasting contribution, to author a bit of history, a great story that never ends. Starting off as Nagarjuna Construction Company Limited, close to 4 decades ago,
It is visible, right? Hello? Hello?
Yes, it's visible.
Okay.
Visible and audible too.
Okay.
we have worked unceasingly to expand our capabilities, our scale of operations, and our reach. Rechristened as NCC Limited in 2011, we are today a multifaceted infrastructure group with several focused divisions whose activities span the gamut of infrastructure space. The NCC saga has thus far unfolded not just across the length and breadth of India, but also on the international shores of UAE, Oman, and Qatar. The company's projects in the sectors of buildings and housing, water and environment, electrical, power, roads, irrigation, mining, metals, railways, and international have made it an integral part of India's infrastructure landscape. At NCC, history is being created every moment. History that we can actually use to change the course of tomorrow.
Thank you very much. That was indeed very interesting. Now to move on, friends, we'll go to the last speaker of this evening, who is Engineer Kshemendra Nath. To tell you a little about him, he's the founder and director at Resilient Energy India Private Limited, managing director and CEO with 16 plus years accomplishment in this field, and of course, providing strategic solutions within this construction industry. He's adept at overseeing complex projects and leading territory efforts to accelerate the very concept of market penetration sales with the environment always at the back of his mind. Let us get to know about him. But before that, I would like to request all of you, hang on. This seminar is just part one of Think Beyond Green, and details of the next part will also be coming to you. Moving on, a little more about Kshemendra Nath, about the company that he heads. Resilient Energy is an associate of Sintef Norway in the Indo-Norwegian construction and demolition waste management in India, a project funded and also into many other fields. For example, he has led several European multinational companies in India for over 12 years. And also, whatever he will be telling us is based on long experience of having witnessed multiple sectors under the construction segment. Over to you, Kshemendra Nath. I would like to request you to keep your presentation to 35 minutes. We are absolutely dot on time, but still, thank you very much. Please, over to you. Continue. Thank you.
Thank you, Priya, and for the kind words. And thank you, Mr. Pulkarni, for having me on this webinar. We just listened to very interesting and very informative talks by the previous speakers, and I really hope that I will be able to add to that the evening today. I will speak on recycled aggregates and use of them, and during the course of the next 35 minutes will be a little bit slow, but maybe 40, 45. I'll be talking about the challenges posed by the C&D waste. Now, when I say C&D, it's construction and demolition waste. And recycled aggregates is made out of construction demolition waste. I'll talk to you about the construction demolition waste rules in India and take a walk through a modern C&D recycling plant. Talk about where it's used in what are the applications in the construction industry, and we have been a part of very interesting pilot projects using RCA in Mumbai. So I'll share with you my experience for it, and before concluding, I'll also talk about the enablers for promoting recycled aggregates. Also, we know it's not rocket science; it's very simple, but then we are not using it to the extent what we should be using, and what actually makes these enablers we need to look at so that we can use more of recycled aggregates. The picture you see on the right side is the London Olympics Aquatic Center, and it's a wonderful structure there. It's made in self-compacting concrete form finish, and 30% of the aggregates was recycled aggregates. So you can see what can be actually made with RCAs. What is construction demolition waste? Any waste that is generated during construction or demolition of structures is called C&D. It's not just concrete or bricks, it's also a mixture of many things because we don't segregate these materials at source. So we have demolished concrete, broken bricks, we have cement mortars, we have rubble, we have broken stones, we have piece of woods, plastic, and a bulk quantity of mud, sand, and gravel. So this is how the feedstock would look like in a C&D processing plant.
Sorry to interrupt you. Are you presenting anything on, because you're not able to see it?
You can't see this?
No.
I've shared the screen. I'm sorry.
Just yeah.
1 minute. Okay, sorry.
Yeah, now we can see it, sir.
Okay, I'm sorry. Okay, nothing much. The only picture which I wanted to show you was This picture at the London Olympics Aquatic Center, it's a wonderful structure made in self-compacting concrete. 30% was recycled aggregates in this. This is how normal demolished C&D waste would look like. It's all mixed together, and this is the biggest challenge construction demolition waste management plant would, and we are going to make recycled aggregates out of this. If you look at what is the kind of estimate, if you ask anybody in India what is the total C&D waste that is generated, the estimate depends on which agency you talk to. The estimate weight ranges from 10 million tons an annum to 530 million tons an annum, a difference of 5,000%. It actually tells us how little we know about the waste we are generating. And if you don't know the waste we are generating, it also reflects on what actually, what kind of corrective action can be taken. You know, it's not something which has got been scientifically looked at. Now, if you were to ask me, where would you pitch your total construction demolition waste, then I would say that it's even beyond 530 million tons an annum. Why would I say that? If you look at the C&D waste generation in different countries, China talks about, say, 2 billion tons of C&D waste in a year. By comparison, India at 530 on a ton per capita basis, we are still 0.4 tons per capita. And even if we agree that our construction is not as big as China, our construction activities is much bigger than or even much bigger by big yard than what's happening in USA or Europe, going by the cement consumption we have. So I feel that our C&D waste generation must be much higher than 530 million tons, but then it's speculation. We have been associated with the government of Goa to estimate the C&D waste generated in the state of Goa, and we have also given a blueprint for scientific waste management. In that process, we analyzed the waste stream as well as the volume that was produced in Goa. It started off with GWMC saying that we would not be producing more than 100 tons a day. But then while we did the scientific analysis, we came up with a figure of 525 tons per day. So this is the kind of estimate which, you know, like how far we underestimate the generation of C&D waste. Now, why is it important to understand this? Why is it important to estimate it? And why is it important to actually control this? If you were to see, this waste is inert and doesn't smell. So we don't associate this with as a waste that is like a municipal solid waste, for instance. But then it damages the environment to a very, very big extent. This is a newspaper article which came something around 9 years ago. And 2013, they say that 626 billion tons of C&D waste was generated. And if you were to look at landfill, putting this into the landfill is what we do every time. And if you were to use as business as usual, if you're going to use only landfill to use the C&D waste, then we will need a landfill the size of West Bengal to actually dump all the C&D waste that is being generated in this country in the next 25 years. So this is not a solution. We need to have a scientific management of this. And why is it environmentally damaging? Because this find a way into filling up the water bodies and the low-lying areas. The National Capital Region alone lost around close to 1,500 water bodies due to the dumping of C&D waste. A lot of water bodies in Mumbai is under threat, so is in Bangalore or Hyderabad or you name it. So this is a very big environmental issue. And until unless we take corrective action, this is going to be an issue which will actually create a huge damage, which we are not understanding at this point of time. This is another picture of who are familiar with Mumbai knows about this, the salt pans in the Eastern Express Highway and C&D waste being generated over there. People are apprehensive that this will be used to create some encroachment into the lands. we are into the Mumbai's rain seasons, and every time we have this seasonal flooding of Mumbai, and we have damaged Mumbai to a large extent. If you see, 40 years ago, CIDCO had made 11 holding ponds in and around New Bombay. Now, these holding ponds stands as a buffer to absorb the high tide water and also to absorb excess runoff water. And out of this 11 holding ponds, we have hardly one or two left. The one you see on Kalamboli has now been completely encroached. The picture you see on the right is in Nerul, which has been converted into a cricket field. Now, when we do these kind of damages to the environment without even thinking, and CND waste may not be the real reason for this, but CND waste is used to actually the most cheapest material to use to fill those low-lying areas. And then we complain about BMC not doing anything to control the floods. We are also equally at every one of us have got to see to it that we actually create solutions for ourselves rather than blaming government bodies. Bangalore, for instance, is known as the city of lakes. 937 lakes in 1937, only 80 left today, and out of which only 34 are live lakes. You see on the right side, construction debris in Varathur Lake. And this is, it's only a matter of time before the Varathur Lake also disappears, because this is how we have been using CND as one, to get rid of the waste, and second, to make encroachments. So this is on one side, the environmental damage we do because of non-handling, very bad handling of CND waste. But then what's happening to the aggregates? Indiscriminate development has been a major problem in the whole world. From Dubai to China, reclamation is a very popular development model. Why? Because it's easier to make artificial islands than filling through sand filling than by land. And we all know about this huge paradises which has been made in Dubai, like the World and the Palm Beach. So 500 million tons of sand has been used to develop the world. That is equivalent to 20 million trucks. 1/5 of Singapore has been artificially added, and there's planned to grow another 1,000 square kilometers. Again, how we are using artificials? We are using either the raw sand or the artificial sand. But we are using the materials. We are using the virgin materials to do this. Sand mafia is the most organized criminal activity in the country. It's only a couple of days before, you must have heard the news that one of the high-ranking police official in Haryana was run down by the sand mafia. In Vasai Creek, near Mumbai, around 75,000 men work as illegal sand miners. So we have a lot of issues related to environment. We have a lot of issues which is political, with a lot of issues which are law and orders related. Sand and aggregates are the second most extracted resource in the world, even 9 times more than the crude oil. Aggregates demand have grown 360% in the last 30 years. China has used more cement in the last 2 years than USA has used in the last century. So this is the kind of development activities that is going on in this country. And then if you were to look at the statistics in India, we will also find a shortage of aggregates to meet its projected demands. So the BMTPC estimates that we'll require around 600 million bricks and 400 million cubic meters of aggregates, and another additional 750 million cubic meters of aggregates for road construction. So where are we going to get all these aggregates in the future? Sand is not an unlimited resource, and we are depleting it at an enormous speed. So consider this. We have, on one end, we have a huge environmental problem created by non-handling or mishandling of the CND waste. And on the other side, we have aggregates, which are a depleting resource, which we all know that, we will not leave enough for the next generation to build. So this is using of recycled aggregates. I've said all this to set the scene for you to understand how important it is to use the recycled aggregates for sustainability. 20-25 years ago, if somebody were to say that river sand will not be used in construction to do with only crushed sand, then we would have mocked at him. Today, that's a reality. we don't have enough real river sand is no longer available. So we are in a changing environment. We have to adapt to the situation. And so therefore, a circular economy approach is the best way to resolve these issues. So what's circular economy? Instead of have a linear economy where you extract, use, and dump, you will produce the demolished concrete is used for recycling and put back into the construction. And only not more than 5% of the material goes into the wasteland or the landfill. So this is how we need to approach to actually create a more environmental balance in the future, and also resolve the problem of the lack of aggregates. How do other international, in the international scene, how do the global powers deal with the system? If you look at US, around 23% of the C&D waste is recycled. Of course, in US, you have different states have got different, run at different speeds. So New York has got the most stringent measures, and they mandate segregation of waste at site and allows only dismantling and not demolition of the buildings. Now, this is a very important difference. When you dismantle the building, you are making a planned way in which you salvage the material which can be used later, and then you are using, and then you only use demolish the or the concrete which is then recycled. What we do here is demolish everything, and then what you get is a complete mix of everything what you have. It's very difficult to recycle. UK, around 28% is total recycled concrete aggregates is recycled. In European Union, they have got a target to reach 70%. Singapore and Japan are much higher, have reached much better success in this. They have more than 95% of the aggregates are recycled, and South Korea is somewhere around 36 to 45%. So we understand where we stand in terms of the international scenario. One of the best way to actually make it happen is to put C&D taxes, waste tax, like that has been introduced in Hong Kong. So if you use 100% of the waste is utilized, then the tax is $27 per metric ton. And if you use only 50% of is recycled, then you pay a much higher charge. The landfill tax in UK is around £100 per ton. So if that causes a deterrent, then more and more people will actually go in for using the recycled aggregates. We are so far away from where the rest of the advanced world is. But do we have a C&D waste management rules? Of course we have. In 2016, the government came up with, the Ministry of Environmental and Forest came up with the C&D waste management rules, which talks about source segregation. That is, materials have got to be, the waste have got to be segregated in the sites into material which can be recycled separately in a different manner. Mandated use of recovered material, that is the urban local bodies and the private builders should be mandated to use the recycled aggregates as a mandate. The whole policy is based on the polluter pays principle. That is, if you generate waste, then you have to pay for its processing, and then it outlines at various arms of the government and timeline for various milestones, most notably for operationalizing waste processing facilities. Although, this also talks about how do they classify between a large project and a smaller project. Any large project which produces more than 20 tons a day or total of 300 metric tons should have segregate the waste into 4 streams. That is concrete, soil, steel, plastic, and metal, and then bricks and mortars. So what happens is that the chances of you recovering these concrete aggregates or other material without mixing of the other materials is much higher, and you get more value out of the material that is being recovered. Waste management plan to get approval before demolition renovation. Wonderful. We do have a lot of rules on paper, but unfortunately, we do not have we do not implement these rules to the final. Then that is where we actually fail. Demolition and deconstruction I talked about. So deconstruction is a method by which we should be actually looking at trying to recover the material and also make use of this. It's very important to understand this from the context of recycled aggregates, because if you don't really do a deconstruction and if you don't segregate, you might still be able to process it, but then you'll not be able to get more aggregates that can be used back into the construction projects. This was the timeline given by the C&D rules. And if you look at this, cities with 1 million population should have been having operational C&D plants in 18 months from March 2016. So we are woefully short of it. The last update which I have is that out of the 45 cities in India with 1 million plus population, hardly 10 cities have got any operational, only 10 cities have got operational C&D facilities. So we are woefully short of getting this implemented, and we're still continuing like business as usual, which is sad. But having given the background, what can we do? And I would like to take you through a walkthrough to a modern recycling plant, a C&D recycling plant. This is a plant which has been put up in Thane, in Shilfata, under the Thana Municipal Corporation, under this Ministry of Environment C&D rules. So I will take you through it, and then I'll stop and explain so that you understand understand this as an overview. Now here is the plant. It's a series of hoppers and then conveyors, belt conveyors, and then you have a proper processing unit out there where it cleans the aggregates, separates the material, and then uses and then screens the aggregates into different sources. Here you see the feed hopper. Now, this is where the mixed C&D waste, which comes from the municipality, goes in, and it is fed with a grizzly vibrator. Oversized aggregates, mostly 80 mm and above, is screened off, and this is then taken out through a conveyor up there to the cleaning unit. And what you see over here is metal separator. You can see here a magnetic separator where it picks up the metal and other materials. It goes into a Rotomax and a log washer. A Rotomax is where actually the old aggregates, which has got the interface of old concretes sticking on to the surface of the aggregate, is removed to the maximum. And then a log washer is where the plastic and other lighter materials are segregated, so that you then process only the good quality aggregates. So here it is, the plastic and materials going, and then it is going through a high pressure jet cleaning system, and then the cleaned aggregates goes down to a series of screens. So depending upon what sort of aggregates you need to make, 4 plus 4 minus 4 plus 75 micron makes you aggregates, sand, and then you can have screens from 10 mm down or 20 mm down. So basically, there is no crushing involved in it. You're only processing the material which has come in by segregating the metal, segregating the plastic, and then sieving it, and then segregating it by the right particle size. So after this, the material is segregated into different heaps, as you can see here. And the water is then taken into aqua cycle, where material which is less than 75 micron is then used. Flocculant is used in the aqua cycle, and the sludge is settled into it and then used out to take the used as in the filter presses and then taking out to the dumping yard or to the landfill. So here is this plant, and such plants have been installed in more than 10 cities in the country today, although we are supposed to have more than 40 of them by now operational. Now, what do we have seen this mixed waste that is being actually used from there are various things which we need to control here. If your feedstock has got mixed waste, then what you get is called a recycled aggregate. You have to make the differentiation between the two. The concrete waste or a pure concrete waste is called the recycled concrete aggregates, and this is what is mostly used into construction. So RCA or recycled concrete aggregate should not have more than 5% bricks. Recycled aggregates is a mixed waste. So you can get good quality aggregates with RCA, and this is allowed to be used into the concrete because now the IS 383 has allowed use of RCA into some parts of the concrete, lean concrete in particular, much more than structural concrete. So after processing, let's look what is the input of the CND waste. This is some statistics we have taken out of operational CND plant in Burari in Delhi. 36% of the input material is sand, soil, and grain and gravel. You have 31% bricks and masonry, 23% concrete. Then you have some 5% metal, 2% bitumen, 2% wood, and then 1% which is all sorts of plastic and the stuff. And after processing, they have been able to achieve something like the products of 22% is loose soil, which is used for gardening, 26% is mixed brick base, 12% is granular subbase, which goes into the construction of roads. 27% is manufactured sand or sand used for construction. 11% is used in precast, where they have their own block manufacturing facility. And look at this figure, only 2% goes back to the landfill. So effectively, you can actually take that mixed material and create some value-added material over here with only 2% going into the landfill. And these are all actual statistics from operational plants. If you don't have mixed waste, there's another option available. If you have a large construction site where you need to do the demolition and you are more sure about the source of the aggregate because you got to deconstruct that building, you can use mobile crushing units. These are all very good equipments today, which is equipped with soundproof enclosures, and also with spraying systems so that there is no water and there's no damage to the environment resulting from dust, with a good dust suppressing system. It can process around 50 tons per hour. And this can also make equally good concrete aggregates. So horses for courses, if you have a material which is mixed waste, then it has necessarily go into a CND recycling plant, which I showed you earlier. But if you have a large construction site where you can use mobile crushers, which can actually make you very good aggregates as well. So this is what IS 383 2016 has allowed the use of recycled concrete aggregates. In plain concrete, RCA as a coarse aggregate can be used at 25%. In reinforced concrete, 20% up to M25 grade, and in lean concrete you can use 100%. But recycled aggregates, which I spoke to you earlier about, which is made from brick bats from the mixed waste, cannot be used in plain concrete or in the reinforced concrete, but it can only be used in lean concrete. And RCA as fine aggregates can be used at the same resource, same percentage replacement as in as for the coarse aggregate. Now, unfortunately, the IS is not very clear about whether this is either or. Either you can use coarse aggregate or fine aggregate. This is a little bit ambiguous, but leave it as it is. Even if you take a 25% replacement, it's a step in the positive direction. And if you are looking at internationally, where the rest of the country, rest of the world is, in UK, RCA is used at 20% up in 20 to 40 MPa concrete, where there is no chloride exposure or freeze thaw. Rice recycled aggregates, which is a mixed material, can be used at 100% only in non-structural members of 16 MPa and below, and only mild exposure. Australia has got two classes of RCA, class A and B. Again, depends upon how pure the feedstock is. 30% is maximum substitution, and up to 40 MPa concrete we can use. RCA class 1B has allowed 100% mixed substitution up to M25 or C25. So you have, this is just a snapshot for you to understand that we have made a beginning, but the rest of the world, where they have been using recycled aggregates and they've got a track record to prove, they have been moving more further ahead to increase the replacement levels. And this is the direction in which we need to go as a construction industry and as specifying bodies in this country. So where do this material, where can we use this material? If only 20% can be replaced in concrete, but concrete is not the only thing which is used for making construction. This material, for example, the brick chippings, which can be made with the mixed waste, can be used as drainage substrate for the green covering of the gardening. Sub-base for the roads is a very, very important application, because you can actually use this material as substitute the use of virgin aggregates, which can be used for better concrete. Loose soil, as you have seen earlier, 30-31% was in Burari. We had around 30-31% sand and gravel. It can be used for landscaping and gardening, garden furnitures, concrete benches, blocks and pavers, concrete, and brick sand. Now, what happens to us engineers or concrete users is that the moment you say that you can use only 20%, everybody wants to say that we want to use more, because internationally more material is being used in other countries. But if you make the first step, what is the potential we can actually replace? And I did a quick maths based on the consumption of building materials, concrete, or the building materials of cement, basically in Mumbai, the MMR area, or the Mumbai metropolitan region. MMR consumes something like 7 lakh tons per month of cement. That's around 8.5 million metric tons per annum. 30% goes into infrastructure, 58% into housing, and 12% into precast products. Now, this is the kind of figures which I got talking to the industry experts or the people engaged in this business. So if you make a rough calculation, but mind you, this is not correct to the last metric ton. Approximately 13 million cubic meters of concrete is produced in the MMR region, 25 million concrete blocks, 16 million pavers, 2 million hollow blocks, 2 million curbstones. Now, this is roughly the kind of material that is made out of the 7 lakh tons per month consumption of cement. Now, if you were to look into the aggregate consumption, we need, MMR takes around 60 million tons of aggregates in a year. This is the annual demand. What you see over here are the clusters. The red spots are the clusters of the aggregate quarries today. And people who have been in this business for the last 30 years would remember that the blue stars were the actual quarries from which the material came and which the material was servicing the Mumbai area. So obviously the aggregates quarries have gone further ahead, and also the cost have gone up, and the transportation has gone up. 40 million tons of aggregate goes into cement, concrete, the concrete mortar and plaster business. 1.2 million goes into precast products. 12 million tons goes into roads for the GSB, or the ground subbase, granular subbase, and 4 million tons goes into asphalt and backfill. So this is the rough breakup of the aggregate going into different construction segments. Now, if you were to look at added to 15% of the concrete. Now, this exercise I did to actually understand that if you had the potential to use all the recycled aggregates, how much of aggregates can be recycled aggregates can replace the total demand and it's a staggering 30% of the total aggregate demand in MMR can be recycled using the current provisions made in 383. And that's not a small figure. So if we were to make the steps in the right direction, then we will be able to reduce the environmental impact and also preserve this material, the virgin aggregates, for the next generation to build. What are the enablers for the thing? Of course, there are a lot of things which the government needs to do in terms of policies, financing, collection efficiency, which I will not go into because I will talk about more into confidence building. Because it's a new product and we don't really know whether we can actually use this in structures without having any detrimental effects. So quality systems are a very important aspect. And what do we actually do to do that? And also develop wider applications so that we use our imagination to use this material more and more so that we can save more precious aggregates. So C&D process metal can be highly not as close. It will not be as close as natural aggregates. The input material source can have deleterious material. For example, if you are using from a C&D plant, the construction demolished concrete could come from a chemical factory for all you know, and it could have some embedded chemicals inside that. So you can have deleterious materials. And if you don't really check and certify and have a process, then you might be using these materials into a concrete which is not desirable. Then we need to document the process, and operating the quality system is very highly critical for building the confidence, because as a structural concrete user or a specifier, this is of extreme importance to have it. So therefore, we need to have a proper certification of materials for use in structural concrete. And once we have it, and when we start using it, we need to demonstrate the ability to produce quality aggregates and use in higher grades with higher replacement. So this is the challenge we have. So where we need to, how do we actually make this? We need to have a very good quality system. We have to certify the material which is coming in, and we need to have a proper documentation of this testing which is done to the thing. And if we have that, then probably we'll be able to have more confidence in using the recycled aggregates. This is some of the work we have done for Burari in Delhi, where we have done specific gravity timeline analysis of the material which is being produced, and look at how what is the movement of the material, how consistent or inconsistent they are. Water absorption is one of the biggest, something which people find it undesirable because it's got a very high water absorption. If 3% is a water absorption of natural crushed fines, then this will be somewhere around 8 to 9%. But as long as it is consistent, you can make allowance for that in the mix design. But to certify that and to test it is the most important factor. Again, I talked about that deleterious material. You need to also test and document what is the acid soluble sulfates, acid soluble chlorides, and compare it with the benchmark which is allowed in the IS. So it's very important to have a robust quality system in place. We need to monitor the materials, and then only we have the confidence to use it. And more we use it, then probably we can go to the next step where UK is, or US is, or Singapore is in terms of using this recycled aggregates. Do we have time to do that? I don't think we are running. I really feel that we are running against time. We are depleting it at a large speed as if tomorrow doesn't exist. But I can tell you for sure that we need to pull up our socks and work at it. I'm very happy to share two projects what we have done in Mumbai. And one is Godrej Sintef full-scale RCA project. Very, very interesting project. Godrej has got block manufacturing unit in Vikhroli, and we did a full-scale project looking into a different aspect of environmental zinc footprint, which I'll explain this over here. And also the second
5
project
minutes to
was
go, sir.
L&T's precast factory grade slab for the Sidco mass housing. These two are live projects which we have executed, and I will just go through some of the highlighting features. In this Sinter project, for the Godrej project, the objective was to demonstrate the added value of using concrete blocks with recycled aggregates. So the comparison is blocks made with natural aggregates and block made with recycled aggregates, and what is the advantage of using recycled aggregates in blocks, especially from CO2 binding, carbon dioxide binding properties. And there's a very interesting aspect which is currently being investigated globally. And we documenting the technical performance in every stage. Natural CO2 binding by carbonation is a very important aspect in reducing the CO2 footprint. Calcium oxide, we know calcium hydroxide, reacts with the carbon dioxide and forms calcium carbonates. This is carbonation, because what happens is that in structural concrete, it is something which actually is a cause of worry, because if you have depletion of calcium hydroxide, which increases the passivity or keeps the passivity level of the concrete very high, if you deplete it, probably you'll have no risk of carbonation. But in a non-structural member, especially in blocks, there is no reinforcement to protect. So carbonation is a good thing in that. Why it is good? Because it has got its ability to absorb carbon dioxide from the nature and bind it within the system. So this will improve the carbon footprint of the material. We had the first speaker talk about the LCA, and good. I don't really have to go back into explaining that, but life cycle analysis, you actually analyze the carbon footprint of the structure right from the material, from what input material has been used, and the carbon footprint of that up to the carbon, which is carbon dioxide, which the impact of CO2 in its life cycle, and also after demolition. Now, the European standards today have allowed the use have allowed the CO2 binding properties of the material to be used in the environmental product declaration. So if you use a particular material which has got a higher CO2 binding properties, then the impact, the positive impact of that can be calculated or factored into your life cycle analysis. So if you have an aggregate which is recycled aggregates, blocks made with recycled aggregates, which will have a higher CO2 absorption compared to a normal aggregate block made with normal aggregates, then it will improve your CO2 binding properties or your CO2 footprint. So this is the project. What you see is a Godrej block manufacturing unit in Vikhroli. They have got also a recycling plant. It's a dry plant. It's not the wet plant like I showed you earlier, but then they have a single source material, right, which they can use for making the demolished concrete, for creating recycled aggregates out of that. So this particular project, those who are familiar with Mumbai, this is Mars Hotel near the Mumbai International Airport. There was a double basement and the slab, which was demolished because there was a change of property, the change of owner of the property, and they wanted to build something different there. So 42,000 metric tons of debris was there, and you can imagine this could have all found their way into the low-lying areas like we talked about earlier. What we did is that we we organized, we licensed and coordinated with the demolition contractors on behalf of Godrej, and then we also documented the entire quality processes that needs to be followed from the demolition right to putting it back into another structure. Here you see the first step, what we did was to measure the carbonation of the existing concrete. And so we made a complete grid of the block and then choose some points at which, random points from which we drew the sample and looked at the carbonation to estimate how much of the concrete had already carbonated. We got it tested at the Bureau Veritas lab. And as you can see, although the structure was 20 years old, the carbonation was much, much lower than what it is. Only in a few places you had some carbonation effect. Having documented that, we followed it up with the actual construction, crushing of the aggregates. We made representative samples. We collected sample every hour of production. So 5-6 times in a day. We made a composite sample which we sent to Norway for their testing, and the hourly sample we got tested at the Bureau Veritas lab in Mumbai, so that we document what is the critical properties of the aggregates. So here you see, we looked at the fineness modulus. We looked at the specific gravity, the water absorption, which is a very, very critical component, the dry loose bulk density, the rotted bulk density, and also the particles passing 600 micron and 150 microns. So you can see that this material, even though it is a recycled one and not processed like in a wet plant, you have a high degree of consistency, both in fineness modulus, in specific gravity, as well as in the water absorption. Now, as I said, the water absorption figure is around 8.5, but as long as it is consistent, you can make allowance in your mix designs, because then it's not varying and the water demand doesn't vary. Even DLBD. So we had an excellent product. Look at the fine material which is below 150 micron. If you were to say it behaves much better than the normal aggregates, which is drawn from from the different quarries. So I'm not saying that this is a replacement, but you can make very consistent material if you do the right way in which you can actually document and control the production of it. We made blocks out of it. These blocks were actually tested for its mechanical properties. What you see is one block which we took all the way back to Norway. So as soon as the concrete block was ready to be lifted, we wrapped it in a polythene so that no more carbonation takes place. And yeah, this is the test certificate. And we took this, we tested this in Norway. I'll come to that test results. I'll discuss this briefly later. So this is the blocks which was made, all passing the IS requirements for the concrete blocks. And then all these blocks were found their way back into the metro station building in Are Colony metro station. So here it is, the blocks demolished from, concrete demolished from Andheri, processed in Vikhroli and back in Goregaon. So this is a wonderful example of how the circular economy was put into practice. Of course, this is just one particular project, and we hope that we'll be able to do more and demonstrate this in a bigger scale. Carbon dioxide binding, I'll just briefly tell you the preliminary results. The blocks were crushed and exposed to varying relative humidity, and CO2 binding was measured. And at concrete with regular block had lower carbon binding for CO2 binding ability compared to the concrete with RCA, which and when the relative humidity is lower, the effect is much more pronounced. At a higher relative humidity, the difference is not much, but still there is. So the reason why you have this is because you have unhydrated cement which is clinging on to the aggregate surface in recycled aggregates, and that added with the already CaOH, the calcium hydroxide within the system, within the body of the concrete, is giving you more ability to bind CO2. So this is an important factor, because in precast material, if we can bind more carbon dioxide from the air, it also helps you to reduce the CO2 impact in the overall picture. And finally, one more project, which is another interesting project for L&T in Ulve in New Bombay. They have bagged one of the biggest packages under the Prime Minister Awas Yojana. where 5,000 crores of built-up area of for 5,000 crores and a built-up area of more than 17 million square feet. So out of the 17 million, around 4.5 million square feet of projects was using the precast large concrete panel system. So for this, there was a huge factory floor that has got to be produced, and we used recycled aggregates from Thane and transported it all the way, and then put it into the concrete over there. So here is the plant. What you see on the right is a plant which I've shown you the video of. We got sources of aggregates, the concrete from metro line in Thane, and transported it to the metro waste handling. This is the name of the C&D waste handling organization, metro waste handling. And we got periodically tested according to the same way in which we got the material tested for the Godrej, and it was used in the ground space lab. So here you see how the material was monitored, certified, and then used into the concrete. So more than 490 cubic meters of concrete was laid using recycled aggregates from Thane into this. And after a year, we went and looked at the concrete, and the concrete was looking very good, super good. We used more than close to 270 metric tons of RCA. We could have used more, but unfortunately, there was no feedstock coming into the plant. And this is a very typical example. Water everywhere, but not a drop to drink. There was no good quality feedstock of concrete available at the recycling plant for us to get it. Otherwise, we would have done more of it. So in conclusion, I would say that recycled aggregates, use of recycled aggregates helps in safeguarding the environment, because if we don't do it, then we are definitely damaging the environment beyond imagination. For this to be effective, you need good government policies, not just on paper, but effectively executed. And until and unless we do that, we will not be able to make a successful investment in C&D waste management policies. Recycled aggregates have got a huge potential to partially replace the fast depleting natural aggregates. We did a case study in Mumbai, and we know that roughly about 30% of the natural aggregate can be saved if we were to convert that into recycled aggregates. So that is the kind of potential we have. And we should use a mix of regulations and standards to set the framework, and also guide the private sector to adopt good practice. Because one of the key things is to make sure that we have a robust quality system. It is properly documented, it's certified, so that a structural engineer or the builder or the owner of the structure is at ease, knowing that this can be used without any issues. So if we don't do that, the alternative is that we find another planet to live on, because business as usual is not going to help us. With this, thank you very much for your attention.
Thank you very much, Kshemendran sir. And over to you, Parashar, for Q&A if time permits.
Yeah, the lecture was quite revealing. In the sense, I thought that there should be no construction anymore, but that cannot happen.
I can't hear.
Are you able to hear me now? Are you able to hear?
Yes, we can
Hello?
hear you, Parashar.
I guess the sir is not able to hear.
Yeah.
Yeah. Okay. So, but just one question that I had in mind. See, like how many times can we recycle concrete? In the sense, like, yeah, we recycle the fresh concrete during demolition. We convert it back into blocks. Now, can it be again reused? Is there, because at one point of time this is going to grow old?
Yes.
Say like 30 years.
Yes.
So how many times do we feel that this can be really recycled?
See, the biggest issue we need to address in this is the transition zone, where you have the old concrete clinging on to the aggregates, the aggregate surface, and that actually interferes with the bond, and also have generates higher water demand. So as long as we can have effective solutions to reduce the clinging concrete, the old concrete which is clinging onto the aggregate source, and 30 years from now, hopefully we'll have better technologies to make sure that this is also addressed. So I think we'll make the first step first, and then take it when we reach there. So
Perfect.
I don't see, otherwise I don't see any reason why we can't recycle the same thing, because that should be possible.
So currently in any of, if you want to specify this particular product, the recycled aggregates into our specification, so how should we go about that in our smaller building projects?
Yeah.
Or any building project that too?
Yeah. See, the first thing, as I said, is to make sure that you have a proper quality systems, documented quality systems in place, which certifies the material which is being used. Now, then second thing is that it should be sourced from a proper source, or like a C&D facility which follows this material, the quality processes. So once we have these two things in place, then you can definitely go ahead and then specify this. But I would still say that it is better to use in lean concrete or road sub base and non-structural, where the critical parameters like chlorides and sulfates and all are not not creating issues. So non-structural is the best way to go. Lean concrete is another place. There's road sub base, and even if you use this blocks, definitely, and pavers, definitely you can use it. And yeah, that's where I would.
Perfect. I guess so. That's the kind of questions that I have. If anyone else would like to ask some questions directly.
Parashit, I would like to ask one question. Kshamedranath.
Yes.
The topic started with reducing carbon footprint and using material which is greener in characteristic. So when we are manufacturing recycled aggregate, can we say what is the emission? Because ultimately we are crushing, screening, and washing, etc. So have you any log that how much energy has been used per cubic meter or something like that? One simple example would be parameter would be cost. At what is the cost for recycling? Second is how much diesel is, because primarily all the equipment or machinery appears to be diesel operating. So how much it is there any parameter study that so many liters per ton or something like that?
Yeah.
Do you have that?
Yeah, I don't have any figure to tell you, but what I can definitely say that the power, the energy impact of this is much lower than running a crusher. For example, your crushing activity is much low in this because you are only cleaning and then you are segregating this. So there is no crushing involved, but definitely there will be a jaw crusher to reduce the size of it. But overall, although I don't have any figure with me, I think the power energy consumption will be much lower than natural aggregates. Second thing is that, what is the alternative? Do we have, can we dump it? Can we still continue dumping it in the, so there are in the landfills. So we need to also look at, and then how is the cost of replacing the virgin aggregates, because we have to leave something for the next generation also to build something. So it's the overall picture we have to take. Yeah.
So that point is agreed. So whenever, otherwise we have to generate a space for dumping the debris and once again excavating more and more aggregates. So it is something like using solar energy, for which we use solar panels, which themselves consume energy in manufacturing.
Exactly.
So okay, let us not go into that debate. Thank you, Kshamedranath. Very useful lecture, very good insight, because this is something which we had not thought of. Over to you, Dhwani. Sorry, over to you, Priya. Priya.
Yes, sir.
Priya is there or no?
I was
Yeah,
on
please,
mute.
yeah,
I was on
yeah, she
mute.
was mute.
Yes,
We can close now. You
we
can.
can close. Yes.
uh,
Ladies and gentlemen, we are on time, and I'm very happy to say that this was part 1. Stay tuned for the part 2, which will soon be coming. And do give us your reactions, give us your feedback. It has been a wonderful session because we learned so much. I can understand that the time allotted was not enough, but still, I believe a window to something opens many doors and not just one. On this note, I would like to thank everyone present here, and not only the speakers, our 4 speakers for today. I would like to also thank all the audience, which was extremely receptive. They asked wonderful questions. Again, we apologize, we can't take all the questions. And from Wide Angle Forum, particularly, I would like to offer a bucket load of thanks to my friends at Epicons Friends of Concrete, particularly Jayan Kulkarni sir and Parashar Moge. Thank you very much. And remember, we had asked a few questions during the run up to this, a few simple questions about our blue planet, and all the winners will be getting their small gift. Thank you. Have a wonderful weekend. And stay tuned for more.
I will also add few names for the vote of thanks.
Yes.
NCC, Nagarjun Construction Company, we say thanks. We particularly thank Suhas Eklere, who was responsible for taking initiative in getting sponsorship. BDS, Mr. Dhananjay Kulkarni, has also offered a small sponsorship. Apart from that, from College of Architecture, there are 2 colleges who participated along with their student. One is Viva College Virar, principal is Chakur Mehta, and second is Thakur College Kandivli, principal is Dheeraj Salotra. These 2 principals took special effort to get the student also for this particular webinar. And since Priya has thanked everybody, I have to thank Priya for being anchor and is a quick sort of a display of what services we offer as Epicons is structural design, proof checking, structural audit, assessment and identity, concrete quality monitoring, project management, architecture and detail engineering, but above all, training through EFC. With this note, I would like to thank everybody and close.
Thank you.
Okay, thank you.
Thank you.
Thank you
Mr.
everyone for your
Kulkarni.
Thank
time.
you very much.
Thank
Good
you.
night.
Have a nice weekend.
Thank you. Bye-bye.